deal with this for now. Hi there, Adrian. Hi and welcome. Hi and welcome. Hi and welcome, Adrian. How's your day going? How are you doing? How are you feeling? I'm going to actually make myself some coffee, I think, because we're going to have a lot to do today. A lot to do. 6 is more than 5. I know that 6 is more than 5 because I don't, like, I won't be able to finish it in 5 minutes. I need like at least 6. My day was good. Oh, really glad to hear. Really glad to hear. Have you thought some more about what you would like to do, by the way? Just general Blender or something more coding-wise? I will be honest, recently I also realized how much work there is to do on the website, and that just, well, it shook me a bit. I realized that there are a lot of things that need to be done. But I promised myself that I would first finish the harmonic oscillator video and only then get to serious work on the website or the tenet. So, yeah, I'm starting with the website. I mean, the harmonic oscillator. Yeah, that's what I meant. Okay. And so that's what we'll be working on today. We'll be working on the harmonic oscillator video. Once again, I'm finished making coffee. Because probably with this. And then we also open up Premiere in the background. And since we're still waiting, honestly not really. I would like to do Blender mode encoding, but it depends on what I had to do. Once again, don't think about it in terms of what you have to do. Because I really don't want you, like, you are volunteering, you're doing us a huge favor. And I don't want you to, I have worked for corporations in the past, and let me tell you, it sucks. Actually, let me turn off the kettle for now, because this is important what I want to say. I have worked for corporations in the past, and let me tell you, it sucks. It's awful, it's horrendous, and I hate it. And I don't want this sort of, I don't want that kind of environment here, because that is a horrible environment. So if you're just volunteering, then I absolutely don't want you, I don't want to force you to do anything you wouldn't like. And if you'd like to do Blender, that's even better, because there are also things that need to be done with Blender as well. So, back to the boiling. Hi to you as well, and welcome. I know I would like to learn everything. If one day I just see something else, but I feel like it's free. I mean, I definitely would like also to teach you some Python, but that's simply because no matter what you are doing in life, it can almost always be made easier with Python. It's really difficult to find a task that requires some kind of thinking that cannot be made easier with Python. Not solved with Python, because you can't really solve most things with Python, but almost everything can be made easier with it. Alright, there we go. Harmonic oscillator video. But if you'd like to start with Blender, then first I would ask how familiar are you with the controls of Blender and everything? Because that's the first important thing, which doesn't actually have much of a knack to it. That just needs something you need to be used to. So moving in 3D, so stuff like moving in 3D, stuff like switching between tabs, stuff like just having G to move things, F to scale things. Let me give you an example of what I mean. First thing you need to be familiar with is just the controls. So how you move, how you rotate, how you zoom in, how you orientate yourself, how you can center on an object, right? Press G in order to move, GY, GZ, GX, rotate around a specific axis, rotate on a specific plane, which is equivalent but still quite useful. Scale on an axis, scale on a plane, rotate and scale on the X or scale on the relative X. Stuff like these are just very useful in general if you'd like to be. And unfortunately, there isn't much of a secret to it. This is just something you would need to get used to. So how familiar are you with Blender when it comes to just operating with it so far? That was my first question. So I'm going to play myself some music because I need to. Well, there's a lot of work to be done today, isn't there? Let me turn this off as well. That's because we need to animate. I'm actually really pleased with this animation. It is pretty good, all things considered. I mean, it's not bad. But even better, we can actually move this down, now I think about it, and we can cross this off. Yeah, no, because the sphere ends way too early. I do like this animation. It's really smooth. I just saw I have 30 seconds of delay, so sorry for not answering. I'm not really familiar with controls, like moving things I know, but scaling I don't. Okay, so let me just give you a brief introduction. And as well, I'm going to save this as cube hit by a tab. Alright, so I would really like to keep things for now, so I'm just going to hide them away to make everything easier. Okay, right. I'm going to guess that you would like to do Blender the way I do it, because there is also the art of doing organic shapes in Blender. And the problem with doing organic shapes in Blender is that that's a different kind of warmth. When it comes to technical abilities, doing organic things in Blender isn't much different from doing what I do. In fact, I have done organic shapes as well, but doing organic things requires a lot more of an artistic skill and talent rather than Blender's skill and talent. When it comes to Blender and Zone, here's the thing. You have your object, your default cube, everyone's beloved. Hi there, Figgy, by the way, hi. Rotating is A, scaling is S, moving is G. It may feel a bit weird. Hi above as well, hi and welcome. It may feel a bit weird for these, like rotating A, scaling S, and moving G, but the reason why G is because G is just closer. So if I rotate, all I need to do is press A. If I scale, all I need to do is just press S. If I move, all I need to do is press G. Then the next important thing is that after you press that button, you can pick a coordinate, which I'm going to note down as XI, because that's how I noted it down on the Maxwell stream yesterday. So for example, I can press A to rotate, and then I can press X, rotate around the X-axis. That's convenient. Rotate around Y-axis. Rotate around Z-axis. Blender is like really convenient with these controls, I would say. Another neat thing is what you do when you press Shift. with these. The reason why pressing shift is useful is because for rotation it isn't, but when you press shift, then you're telling Blender, give me everything except that axis. So for example, if I rotate on X axis, this looks like this, but here's what happens if I rotate on the Y and Z plane. So rotate, shift X. Now you can see that I'm rotating for both axes except the X. For rotations it doesn't really matter, but what it matters for is, for example, position. Because I can move the cube on the X axis like so, and now it only moves on the X axis. Or I can do G, shift Z, and now it's moving on the XY plane. Which is different. If I move it like this, let me show you. If I move a cube like this, normally, versus if I move a cube like this, as you can see, this one changes X, Y, and Z coordinate, whilst this one only changed the X and Y. All of that, as I mentioned, is really simple. There isn't much knowledge to be gained from this. It's just something that you need to get used to. So that's what I would recommend as the first step. And then once again, you can do the same thing with scaling. And one last thing I should also mention is that you can rotate an object to some kind of random arbitrary rotation. And a very important and a really nice feature of Blender is that right now I can rotate this object around this x-axis like so, or I can rotate it around its relative x-axis, which is just a really nice feature, I would say. These are the kinds of controls I would first suggest you get used to, simply because it makes everything down the line way easier. You will find it really annoying dealing with Blender on the very beginning, simply because there is no way about that. Getting into any kind of 3D software on the beginning is a headache because, well, it's unique. Normally applications have 2D interfaces. This will just develop you more like 3-dimensional spatial reasoning. How do I rotate it to the relative axis? You press the axis twice. So here's me pressing R, then X, and then X again. You press the axis twice. But what I suggest you do... Oh, and another important thing. If I'm going too quickly or if I'm overwhelming, then do let me know, because I do realize I'm going over it quickly a bit. Another thing which is neat is that if you press Tab, you can switch to edit mode, in which you can edit geometry, and this also applies. Then right here at the top, you also have... It's great, okay, good. Then if you're saying it's good, then I'll keep going, because I also mentioned the pivot point. That's because if I press S, if I scale this up, which you need to realize that this is actually scaling up the cube, but around a certain point. So it's actually scaling around the certain point, central point, like so. So it's scaling in all directions, right? But now let's say that I have my cube. I move it a bit more to the left, and then I want it to scale around this point in the middle. How can we do that? Well, right here you can see this orange dot. That is the origin of our object. So if I scale up and down, it scales around the origin. But that's only because right here in the pivot points, that's what's selected. We can also select the pivot point to be a 3D cursor, and then it's going to scale around this right here 3D cursor. Hold on, because I never remember. Resetting the 3D cursor is always annoying. I don't remember the shortcut for that. Ah! Or maybe I do. There we go. Cursor to what origin? There, I don't remember. And the reason why it's important is because there are obviously differences. So for example, you can have a median point, in which scenario it rotates around the origin, or 3D cursor, in which case it rotates like this. It's useful for changing things later on down the line, because normally you have stuff like a median point, like this for example. We have a whole bunch of cubes, and let's say that we want to scale them up. Well, there are two ways you can go about scaling them up. You can scale them up like this, or you can scale them up like this, individually. And it's just useful to know the difference. It also applies in edit mode once again. If I cut this in half, if I select this face and then this face, edit mode is surprisingly irrelevant, I would say. It's comically irrelevant, truly. I will also teach you edit mode, because edit mode is like theoretically the main utility of Blender, but it's comically irrelevant considering just how powerful geometry nodes are. Because almost everything I do with geometry nodes, for example. Bar some really, really narrow exceptions. So I would say geometry nodes will be way, way more useful. But once again, we'll only get to geometry nodes once you have a firm grasp of Blender, because then it will just make the entire process way, way easier. But an example of geometry node setup, once again, stuff like this. So if I go to edit mode of this object, you can see that it's just a plane. That's what this object actually is. It is a plane that I have modified using these nodes in order to take on this shape. That's how powerful geometry nodes are. They are really, really mighty. I can edit this plane, by the way, but it won't change anything. Because basically everything is set up in these geometry nodes. They are really, really, really powerful. Anyhow. Now I'm thinking if we should start geometry nodes, or if I should actually give you some more time to get into Blender, because geometry nodes will be really easy, but it's a very different kind of skill from just using 3D software. They're both extremely interconnected, obviously, but how should I put this? It's basically like if you're trying to learn organic synthesis. It's the difference between understanding how equipment works and understanding the chemistry of the reactants. Like both of these are very, very different things that aren't really connected. Their only connection is through the process. Are geometry nodes more similar to coding programming? They are, yes, with a certain difference, which is that, but I have don't know. Okay, then it's fine. Absolutely fine. We can do it another time. I can tell you actually figure exactly what's the difference between geometry nodes and programming, and that's the fact that geometry nodes, programming is made to have linear execution. It doesn't have to have linear execution, but that's a topic for another time. Basically, you have task 1, task 2, task 3. Task 4. And then programming is all about going like this. Are geometry nodes maps for programming? Yes, in a way. I will get to that in a second. So basically, this is how you program stuff. You don't have to program this way. Even on the website, there exists Badger, my beloved Badger, who is a thread, which means they can actually separate, but separating off programming like that is a bit more tricky. It's a bit more difficult. Eventually I might make a tutorial on threading, but that's eventually. It's a bit more tricky, it's a bit more difficult. By default, this is how programming works. When it comes to geometry nodes, however, it is the opposite. Geometry nodes, by default, work like this. There we go. By default, they work in parallel. A simple example of that I could give you is starting the plane. Alright, we're going to start the plane. I'm going to create some geometry nodes for that plane. And then right here, I'm actually going to replace that grid with another grid, simply because it's easier. Okay, so this is a meter by meter grid with 5 vertices. What does that mean? Well, it means that it is a grid, but in reality, it's a grid made up of 5 points, like so, on each axis. So in total, 5 times 5, it is made up of 25 points. I could label all of them if I wanted to, but well, I'm going to very quickly, like so. There we go. Now let's say that we want, so we have this grid, it is made out of these 5 points. I could also increase the amount of points from 5 to something like, I don't know, 20. So now it's made out of 20 times 20, not 5 times 5. That should all make sense. Now let's say that we would like our grid to not be flat, only we'd like it to have like a really, we'd like it to have this kind of shape. Or even easier, parabola, this kind of shape. How would we do it? Well, here's an idea. We can take position of each point. It has a diamond at the end because that means it's position of each point. And then we can set position like so, except vector math, or even separate. Hold on, that would be easy. It could be just separate XYZ and combine XYZ. That could be a bit easier to see. And then the z coordinate, we don't want it to be equal to the z coordinate, only we would like it to be equal to math x squared. I'm going through it quickly because I'll explain in a second, but there we go. This is our parabola. It isn't quite as extreme because we could make it even more extreme by just multiplying by a higher value. There we go. We have our parabola. Now, crucially, this is a very simple node setup that does already something relatively complicated. But why does it do something complicated? Well, it's because what this node right here does is it takes position of each point, and then it's calculated separately for the position of each point, which means that we have a certain point with some kind of coordinate, x, y, z. We take that coordinate, we separate it off, and we say that its new coordinate will be equal to x goes into the x, y goes into the y, but into the z we get x squared times the constant 3.51. And then that's our new position, which is how we get a parabola. That's why I always say that, geometry nodes aren't like programming, because in programming you would handle each of these points separately. When it comes to geometry nodes, it's more efficient to handle them all at once because of some certain graphics card shenanigans. So it does require a different approach, because for example, how do you calculate the slope of a point like right here? If you were doing programming, calculating the slope of this point, because that has very high contrast, calculating the slope of this point is really easy. Pick this point right here, this point right here, and just calculate slope based on their positions. That's simple. But right here in geometry nodes, we don't have a tool to get the position of a specific point, or at least we do have these tools, but they are very inefficient. Which is why geometry nodes require a bit of a different approach from programming. In reality, they require the same approach as programming, except, as I mentioned, this is parallelized. So I would say it's kind of like if programming is algebra, then geometry nodes would be calculus. Okay, that's not that great of an analogy. It's more like programming is all of mathematics. Geometry nodes are specifically calculus. It doesn't mean that it is the same approach as programming, except more specific. I really hope that makes sense. Anyway, I have a video to make. I'm gonna turn that one off and I'm gonna just overwrite it because I've made a mess for no reason. Cube hit by aircraft. Brilliant. This one is gonna be a bit more of a tricky one actually. Definitely makes more sense than before. I really hope, because I wasn't prepared for this explanation, so it was very chaotic. Eventually I will explain geometry nodes better. Okay, here's what we would like. We would like the floor just be a floor. 20, 20, brilliant. Or I could go even further, could go 100, 100, that should be fine. Then 5. Or actually, I think I would like it a bit lower. Let's do 3. Yes, that's good. I like this. I'm going to leave both of these. I'm going to make the volume, because I like my volume. Now that I think about this, maybe would do better as a... No, you know what, this should be fine. Let me look through the script a bit. You're 10, yeah. Horrible. I have to go now. Are you still open to teach me notes this evening? I'll be back at 7, 8. I'm messaging you on this call, but you're loud and no problem, you don't have the energy today. I'll see. I will try to have the energy. It's possible that I will also be live then. I will definitely be working. It depends what I'll be working on, I would say. That was my science exam. What kind of science exam? Don't worry because of me. Don't worry. I'll manage. I'll be fine. Good luck, Adrian. See ya. Okay. Chemistry, great. Ooh, chemistry in high school is rough. It's because it's always so poorly taught. Good luck. Good luck. I'm sorry though, I'm distracted a bit by one thing real quick. I just need to fix it up. Alright, I'm going to get myself a cup of coffee. Because as I mentioned, a lot of work to get through today. And let's carry on. Oh, one thing I could actually try that would be quite neat is... There are repeat notes! No way! I never realized there were repeat notes. Wait, is there an index switch? Oh, there is no switch! Why are the repeat notes if there aren't any? Ah, it's fine. I'll make it work. I'll make it work. So I'm not mistaken. Wait, actually, so we want to keep the scale the same. Oh, how do you... Wait, what? No, that's dumb. That's really dumb. Because I need switches. Damn it. Hi, the roots. Mickey, how do you drink your coffee? Quickly. Hi, the Cassie, I don't. I might be stressed. What happened? Why am I stressed? My phone down. I can't see my exam because my tears are on my phone. Oh shit! Wait. I mean, no. Okay, I see what you mean. I see. When are the exams? Saturday. Okay. When are you having your phone repaired? Ah, my gosh, like a level linear algebra delta didn't give me something. Tomorrow. Okay, that's good. That's something. That's already something. Because if you're having your phone repaired tomorrow, then that means tomorrow you'll have the material for your exams. Thursday, Friday, that gives you 2 days of specific revision. So, I mean, because you know the general topic. So what you can do is you can find the general topic of the exam. Just study it on your own by yourself, and then once you have the materials from your phone, then you can specifically just review them, and then that will just like filter off the knowledge that would actually be useful. I mean, what is the exam on exactly, actually? That is a good question. love chemistry. Good for you, Nostriko. Good for you. Katsi? One is a bunch of technical stuff I don't have notes on. The other one is general anatomy stuff. Okay, then start with general anatomy, obviously, specifically. And I... hold on, let me... Let me try to find something, actually. Because I'm guessing it's in Polish, right? Okay, let me try to find some good resources. It's general anatomy, so I'm guessing all of the systems. Okay, I found one which appears to have quite... Okay. That's not bad, actually. Or do you have sources already? Because there is one that looks like has very similar vibe to the Maxwell's equations one that I've been looking through yesterday. That one looks really nice. I had some on the phone. Yeah, but once again, don't think about the phone then. It's... shit happens, that happened, it's fine. For now, we should look into like some general sources for you so that you can learn based on those sources, and then once you have your phone, you don't have sources. Okay. I would suggest you try with something like this. If it's genuinely... To be fair, that one is pretty rough. Only after a second I realized that it's a bit like just text heavy. But the sources like these. You know, you review using these sources and then you try to prepare to the best of your abilities. Once your phone is repaired, then you look into the sources on your phone, and then they will click much easier. Simply because you've reviewed already using the sources that aren't quite as related. I can move that. Yeah. I really hope it helps. I really do, because it's... I understand that this is really annoying, but you know, you can't let the haters win. You can't let the fact that something annoying happened get to you, because that's what the haters want. He's an idiot. Don't save. I've been editing the core file. Also another thing, I really should have start a new collection for this. There we go. Delete everything simply for the sake of at least a little bit of efficiency. This is a really nice model, but it's way over detailed for what I need. Okay, this should be fine. The inners of the door as well might as well go. These inners can go as well. There we go. There we go. It looks like a commercial so far. Once again, cutscene. I think that's the best course of action. How are you feeling other than that though? Is it just the phone thing, or did something else happen? Just the phone thing, okay. That's always a good sign right here. Oh, this is a really good sign. I'm surrounded by boyfriend a lot. That's really nice, that's really cute. I'm glad to hear that. Certain things appear to break. Okay, objects apply visual transform? No. I was in the stream for a few minutes, now looking at the screen again. Why is there a car? It all makes perfect sense, trust me. There must be a way to apply modifiers to a group, because otherwise there's another way I can handle this, I suppose. You know what, that could be probably better. I can handle it like this. There we go. That works. The only problem is in the wheels though, because the wheels won't be spinning. That's gonna look terrible, unless, oh no, if the wheels are permanently spinning, that's also going to look terrible. There we go. And also, it was in the wrong position. Whoops. Horrendous. Utterly horrendous. Okay, a way we can, well, let's call it fix it, is by taking the wheels. Actually, do we need subdivision? No, we're fine without the subdivision. Joining all of these together. There we go. Even better, we would like to... Yeah, this will be fine. Oh, the part in the middle as well. Why are there always more? Only one of them has the part in the middle. Okay, brilliant. No, two of them have part in the middle, and they're for some reason crossed because I imagine I just merged them weird. Doesn't matter. What matters is we would like all of them rotations to be constant. Their center of geometry isn't quite aligned, but that will not matter. What matters is that I did not in fact bloody let's see. No, it needs a different curve. I would rather not do it with I'd rather do it with an automatic one. The opposite of an exponential, I think. Or just an exponential? No, opposite of an exponential. Would there be like a reverse exponential? That would be nice. Find Bezier. I'll do it manually. Oh yeah, no, X we want to stay like that, that's true. Actually no, we would like the X to back away a bit, wouldn't we? Maybe I shouldn't do it like that, maybe I should do it with... You know, there might be a better way to do it, now that I think about it. I think we need more spin on it. Once again, I don't know why I'm spending so much time on this, because it will be so irrelevant to the larger point of the video. And there goes Katsi. Hopefully to study. It's moving in a bit of a natural way. Let's see. It won't be even visible at this point, to be fair. That's nice at least. Hi, the Panzer. How you doing? Okay, then we can get back right here. Pick all of these. Why? Just genuinely why? I was rotating you around a single axis. Why? It's only one of them as well. Minus 90. Oh, because this one rotated around the... Oh, you are mental. Oh, you are so mental.
That is true. I am so mental.
Oh, this bloody bollock of a wheel is mental.
No,
00360.
I'm mental.
Minus, look at this. Okay, this...
Also, isn't that how wheels are supposed to move?
I also love Christopher Nolan's Dark Knight scene where the Dark Knight drives the motorcycle.
Never seen that.
It's the one where he is considering running over the Joker.
Ah, that one.
Yeah, and then he's, you know, the wheels just spin.
I mean, the ones in my car do that.
Why is it rotating every single way except the one I want? Oh, it's driving me mad. Okay, it's just rotating on every single axis. You are not real. Minus 90 this way and then 90 this way. There we go. My goodness. Genuinely rotating on every single axis except the one I needed. That is hilarious. Okay.
Bigger Nine said, I'm glad Make It Wheels didn't make it to production.
Stay tuned for a special Make It horizontal spinning wheel. I'm going to revolutionize the car industry.
Absolutely.
I've always said we never had enough degrees of motion.
Anyways, I'm gonna crack open a cold can of white.
Alright.
Ah, good.
Because this right here also needs... Oh, no, that's not going to... Unless... Wait, no, it might. Hold on, it might. What we need is a microsphere. That's also going to have a rigid body. It's going to be animated. And hidden. And it doesn't work. Oh, because I need to enable collision. I didn't understand what's the difference between a rigid body and a collision, to be frankly honest.
What is there not to understand?
I don't understand what's the difference between them.
There's lots of difference. Like, for example, one is a rigid body and one is a collision.
What's the definition of insanity again?
It was doing different things over and over again and expecting the same result.
That's the definition of science, by the way.
Well, maybe they're not so different after all.
Yeah, mad scientist, just a scientist, or a mad, depending on... Do you like music background while working? Yes. I do usually listen to music. Because otherwise it would have been mental. To be sitting for hours on end. Different things, picking...
Nanospherical, are you typing on your phone? Because the K and the Y is very far separated from one another on the keyboard.
Is it because I need to bake them? No. Also, I don't remember how to bake stuff. Where's the bake? The rigid
Baking.
body, there we go. Bake from 35 to 600. Oh, actually to 250. Well, no, why not? Well, now it worked. A bit too well, one would even argue. Oh, right, because the cube is in a dumb place. Why are you over there? Because you're not the origin. I was such an idiot. Object set origin to geometry. That's not doing what I know. Origin to geometry like this. And then I want you to be a cube or box. There we go. Yes, now it's going to be perfect. That went way further than I expected. But I'll work with it. There we go. No PC. I'm glad that Nano specified that it's a PC and also felt the need to like include the specs. Is it classical music or some different type? It always depends. I usually play a different playlist each stream for myself. Right now.
Also, sorry if I was seeming a bit absent. I was playing with my cock.
There's got to be a better name for Clash of Clans.
No, there isn't. How to shut up, make it. Say something absolutely diabolical and unheard of.
Actually, what is this? Oh, this is also atrocious. Yeah, not bad. Absolutely not bad. These are not the right frames. What? Figure is asking you when cock reveal.
Oh, I mean, I already sent make it a picture of my cock, so you could just pull it up right now, Jamie. Jamie, pull it up.
Jamie, put out a picture of this guy's cock.
Jamie, pull up a picture of my cock.
This is. That's meant to be science, is what I'm meant to be doing, right? I'm supposed to be the science YouTuber.
Not joking about cock. But here you are.
I'm sorry, are you joking about cock? I thought you were serious. There we go.
Let's say something even more diabolical. And it's just the two of us. And 5 viewers. No. This is not the time and place for this.
Have some decorum.
Yeah. I'm only gonna bring in racist jokes when I need to lighten up the mood. Like I did last time.
Alright. Now, this video will end up being a lot shorter than expected, actually.
I mean, technically this isn't actually a racist joke.
That's not...
Therefore, I can say it. Alright.
Before
If I
you
had a
do,
penny
I
for
have
every
to say...
racist joke I made, then I'd have 0 pennies. Because I'm not joking.
I actually... You know what, that's actually a pretty good question. Would that be a racist joke or not?
I don't think so. Because I'm not being racist.
Well, no, because... The thing is, that's kind of like a racist amplifier, which is if you're not being racist, then yeah, that wouldn't be racist. But if you are being racist, that would just amplify racism even more.
Mm-hmm. Alright. This is science.
We're having the educated debates. Oh.
Or no, and do the this is beyond science meme.
Yesterday there was this fun moment where right as you left the question of the technocrats, and I just that was such a divine intervention of a timing.
Educating the masses.
Oh, why does this brightness diminish?
Also, yes, figure 9. The joke is that I'm being racist. Or that I'm racist.
That's implied.
But is the joke itself racist? That's the question.
What I would argue is that it depends on the context. It can be.
Mm. Alright. Right. I need to add something to your profile. Make it. Don't call him that on stream. All right.
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 Oh,
Anyways, I'm done with my can of white, and I should be running now.
Well, then have a good luck and See, I imagine.
luck.
I'm
need
guessing you mean
endurance, not luck.
literal running.
Yeah, I need to run. Otherwise, I won't be able to get up the mountain.
Alright. Well, then have fun.
Yep. Might join in later again.
Fair.
See ya.
Potentially see ya. Alright. And in the meantime, I've just gotten an idea for what could be the last bit of the video, the conclusion. But not the conclusion. In order to get the conclusion, we need to first record something. So let's get to recording. I'll also be right back, give me a second. I will be right back with you. I am right back. Pure Macaroni entered the stream, make jokes about cookies and raisins in the runway. Yeah, well, such is life of the macaroni. Okay. Let me just zoom in a bit. There we are. Take my take my glass. Move this like so. Yeah, it's not bad, but I would prefer to move it a bit more this way. Why does it feel like I've moved it even further away from the center? It looks off-center, doesn't it? Hold on. Now it looks a lot more centered. At least a bit. So, this is what we did last time. Maxwell's equations. But today we won't be dealing with Maxwell's equations. Only we'll be dealing with a simple harmonic oscillator. We are going back down when it comes to difficulty, quite a couple of degrees, because, well, it's going to be a fair bit easier. Alright. I think I'm just going to record it, since it could be nothing fancy. Give me. Do we need any partial derivatives to solve the simple harmonic oscillator? Let me check. No, it doesn't appear like we do. I think this time we're going to take a bit more of a slower and steady approach, so I'll also record on the stream. Simply because it will be easier. Right, camera action. Oh, there's actually no way to capture the Discord audio. There we are. Now it should be able to capture Discord audio. Okay. Oh, it's not upside down. It just hit me. Hold on. Thank goodness I've caught that before carrying on with the live stream. That would have been a bit... That could have been a bit of a disaster. A bit difficult to read, if you will. There we go. Now it should be... Yeah, now it's fine. Brilliant. So, in the last video, we have talked about partial derivatives. We have actually touched on the chain rule, but we haven't actually gotten a chance to use it. We haven't actually gotten a partial derivative that... No, already fucked it up. It's not a partial differential equation, it's going to be an ordinary differential equation. It just happens to include the chain rule that we're not going to be solving using partial derivatives. So, in the last video on the channel, we have talked about partial derivatives, and we have actually mentioned the chain rule. What we haven't done is we haven't gotten an ordinary differential equation that would actually utilize the chain rule. And funny enough, what a coincidence, a simple harmonic oscillator will actually suffice. So first, let's start by noting down the things that we know. First of all, we know the definition of a force in a Newtonian formalism. So F is equal to ma. Another thing we know is we know what kind of force is acting on... Another thing we know is we know what kind of force is acting on our harmonic oscillator. Mainly F is equal to minus kx. Now you can think about it as just two different pieces of information. F is equal to ma tells us how a force is acting onto our system. And F is equal to minus kx tells us what kind of force our system is actually experiencing. But we can also note down as F is equal to F because they're both forces. Or in other words, ma is equal to minus kx, like so. Let me have a drink. I can't do this sober. Is it free in focus, by the way? I haven't actually checked. I don't think it was. No, I think it's better. This already gives us a pretty interesting equation because we can actually carry it forward. You see right here we do have our minus k, which we can move onto the other side using division obviously, which gives us minus m divided by k times a is equal to x. There we go. That looks good. I can see it on my phone even over the live chat, so it should be fine. Okay, thank you figures so much. I'm glad to know them, because I really should have prepared it a bit better beforehand, but oh well, everything has been spilled. Let me actually really quickly see the recording, just to see how fine it is. Okay, it seems to be fine. Now, why is this equation useful? Why would this equation be ever... fucking, what is wrong with me? Now, why is this equation useful? Why would this equation be useful? Well, that's because we're doing physics. So obviously I'm utilizing a bit of abuse of notation, and this x right here isn't actually a variable. What it actually would be is x of t. That's because at different points in time, our object is in different positions. That's why it actually takes in the time. So in reality, if I wanted to rewrite this, I could rewrite it like so. Minus m divided by k, x double dot is equal to x. What is this double dot? Well, as we have discussed previously in the last video, dot just means derivative in relation to time. So this is just acceleration. The meaning stays the same, it's just notation is different, or rather, more accurately, is the fact that we are no longer considering it as a value of acceleration, only we're considering it as a second order derivative in relation to time of position, because that's just definition of acceleration. So far, we haven't done anything too extreme. Let me think where I would like to take this. Because I mean, solving this is trivial. It's a very simple differential equation. But I do want everyone watching to understand, not even understand, only to think of how this happens. To realize all the importance, let me have a think. Let me have a bit of a think how I want to slice this cake. Hold on, something on this drag racing outside my window. There we go. The actual interesting part of this solution will come in the fact that, once again, why can I never get it right the first try? This doesn't make any sense. The actual interesting thing here, actually Lambo, yeah, everyone wishes. All of this is just us rewriting this equation. But what is the actual goal here? Well, the actual goal would be to ideally figure out what this function is equal to. Because then, if we know what this function is equal to, we can just figure out the position based on any given t. I will elaborate on that more in the future later. For now, let's just say that's our goal. So, how we get around doing that? Well, that's actually pretty simple. Right here, we can rewrite those x's. The camera died. That is hilarious. Give me a second. We're back. I have a backup battery, don't worry. I'll take this opportunity, also zoom in a bit, since if we're not preserving continuity, might as well. Well, that's actually pretty simple. That's because this equation right here already tells us a lot about our function. Mainly, it tells us that minus m divided by k, and then second order derivative in relation to time of our function x of t is equal to our function x of t. This right here is a differential equation. The first one that we're going to solve on this channel. It is pretty simple, but still, we can't take it too lightly. Differential equations are famous for being quite annoying. So, how do we get around solving it? Well, if you've seen my video on derivatives, then you probably know the three solutions or three ways you can get around when it comes to solving differential equations. And those ways are, first of all, using the definition, second of all, using general rules, or third of all, just straight up guessing. And actually, we're going to start the third one. That's because there is something kind of interesting about this entire thing. For now, let's ignore the constants, right? Just take them out using your imagination, take them out and just ignore them. What does this equation look like then? Well, it's minus second order derivative of x of t equal to x of t. Now let's get a little bit of a flashback to the derivatives video. I'm going to double check myself, because I am just that worried I'm gonna get something wrong, and I really don't want to cross things out on this piece of paper. Yeah, that is correct. Yes, that's right. The second order derivative in relation to t of sine of t is equal to sine of t. This right here works. Right here you can see a graph of this function exactly, and you can see that the second order derivative is really just the function itself flipped. So that's already huge progress, because we know right now that if we didn't have those constants, sine of t would solve our equation. However, we do have these constants, and if we recheck our equation right now, we'll see that it doesn't work because those constants are missing. So then another question may follow up. How do we add those constants right there? Yeah, and this one is a bit tricky, because in order to make sense of this, we need to go over the actual chain rule. So we'd like to start with our function and then. We start with our function and then we want through the process of derivation. Well, allow me to rephrase the problem a bit just to make this clearer. We're starting with our function with no additional constants. Any constant will be included into the function. Then what we basically want is we want through the process of derivation to create some constants that our function will be multiplied by. Or in other words, we have our x of t, then we take a derivative. Right here, I'm just going to represent like this because it's easier. We take the derivative again, and what we want to end up with is our function and then some kind of constant right here. So what we need is some kind of way to get a constant for each step of derivation. And the problem with differential equations is that there isn't really an algorithmic way to solve them. There isn't a tried and true solutions that work for everything. Instead, you need to get a little bit clever. So I'll give you a second to think about that and figure out if you're maybe familiar with some kind of process that allows you to multiply a function by a constant through the process of derivation. And there are actually a couple, because I would like to mention a couple instead of just going straight to the answer of the chain rule. That would be a bit too obvious. So we can go with the definition of, we can go with the exponential, we can go with the exponential rules. Yes. Yes, that's a good idea. Okay, second to think over, and I'm certain you're familiar with at least a couple, at least if you've been paying attention in my past videos, because first of them, the most obvious, is obviously the derivative of x to the n, or x to the m, because that's what I wrote down. This is obviously equal to x m minus 1. Right here, as you can see, we took a derivative of our function, and we have gotten another function multiplied by a constant. So this right here, for example, allows us to multiply a function by a constant through the process of derivation. There is a problem, however, that problem being that we already have established we want the sign. We want the sign because it fulfills this minus requirement really nicely. So unfortunately, sign isn't really x to the power of m. That doesn't work. What else have we got? Well, another thing we could try doing would be the derivative of this, but kind of flipped. And by that I obviously mean a to the power of x. That's because if we take a derivative of a to the power of x, what we get is ax times natural log of a. Now, funny enough, it may look on the surface as if we run into the same problem, as in a to the x isn't the same as a sine, and whilst that is true, it is actually a lot closer than it would seem. I will leave on the y for a future video about rotations and oscillations, but basically the point still stands. This does multiply our function by a constant through a process of derivation. Unfortunately, neither of these work with a sine because they both require a very specific kind of function. So, have we got a method for multiplying our function by a constant that involves any kind of general function? And the answer is yes. If you've been paying attention in the last videos, then you're probably already familiar with it and are probably yelling it out into the screen. Because that obviously would be the dx of f g x, like so. This right here is a derivative of a function that has a function on the inside that only then takes in the x. And this is obviously solved using the chain rule. So f evaluated at g of x and then multiplied by the derivative of g of x. And even better, using this rule right here, we know that if x is multiplied to the first power, then what we get is x to the first power would be equal to 1 times x to the 0th power, or in other words, just 1. And due to how a product rule functions, we know that if we multiply all of this by a constant, what we get is 1c. So this right here lets us know that if our function on the inside is just x to the first power multiplied by a constant, what we get is a constant on the outside. It is that simple. Or at least I hope it's simple, because I only now am realizing I've went through a little bit of a lot of knowledge, so. So, what kind of constant are we looking for? What would be our c that has made its appearance a couple of times already? Well, that's easy to check. That's because we know that in the end, we're trying to get m divided by k. But we're trying to get it after two multiplications. So in other words, what we're trying to do is get, this is a different equation on this side, so this x won't mean the same thing as x is right here. X times x, because we derive it once, we derive it the second time, is equal to m divided by k. Which obviously means x squared is equal to m by k, which means root of x squared is equal to root of m by k. X is equal to m by k, and yes, we can take a root of that square because, well, that's just more of a utility kind of calculation we're doing on the side. It doesn't matter, it's pretty simple. Obviously, the constant we're going for is root of m by k, like so. So now, we need to figure out what kind of function, when derived, will give us this m by k. And that we can already guess. But instead of guessing, let's take the actual proper approach. So what we're trying to figure out is the derivative of what function is equal to root of m by k. So what we need is some kind of tool to take this function and get its antiderivative. That tool obviously being the integral. So we're looking for integral of m by k dx. And what we get is root m by k times x plus c. This c is important because whenever you're integrating something like that, you always need to include the c at the end. And so, there we go. This would appear to be the function that we need inside of our function in order to get our result. So the full function would be sine of root m by k t plus, and because we've overused the c a lot, let's just use a different symbol inside, like so. This would appear to be our function. That's what we've gotten in the end. But let's double check, just to be certain. So what we would like is minus second order derivative of sine root m k I've made a mistake, haven't I? None of you have caught my mistake, have you? Everyone watching the live stream right now, I'm going to check how many people have been actually paying attention. Everyone watching the stream, I would like you to look at a piece of paper and try to tell me what is the mistake I have made. Okay, 2 mistakes I've made.
We only have 4 viewers, 3 people.
Yeah.
Can actually answer.
No one is actually paying attention to the maths.
Audience for that kind of stuff.
Yeah, no one is paying attention to maths. Horrendous. I obviously have made a mistake, and by that I mean this right here is m divided by k, when in reality they were supposed to be flipped. It was supposed to be k divided by m. This is wrong. Hold on, I need to do this. There we go. And I am just pouring my heart out. Well, to be fair, I'm recording for this for a video, but still horrendous. Which means our actual solution would be minus m by k, and then second order derivative of our function sine. These, as I mentioned, are incorrect. They were supposed to be flipped, so let's do it right now. K by m of t plus the constant, like so, and we want it to be equal to itself. So once again, sine of root k by m plus t plus constant. All right, let's try solving this equation. So first of all, the derivative of this function right here, what will it be? We only have one thing at play, and that is the chain rule from before. The constants I'll put on the side, they will be very small, like so, and now we're just taking a single derivative, because we're trying to figure out what the derivative of the function on the inside is. This is our f of x, the sine, and our g of x on the inside is the root k by m of t. Right here we have the sum rule, and since this doesn't have an x, this derivative will be equal to 0. So when it comes to the total function on the total function inside, the derivative would be root k by m plus 0, or just root k by m, which means what we get is derivative of the outside function evaluated at g of x, and since the g of x on the inside isn't really changing, it's linear, we can skip that, multiplied by the derivative of g of x. The derivative of g of x I have right here outlined in the end, which means I can start by noting it down. Root of k by m. And what is the derivative of f of x? What is the derivative of the sine? Well, if I'm not mistaken, that would be the cosine. Let me quickly double check just to make sure I'm not messing it up. Derivative of sine of x is the cosine. Yes, derivative of the cosine is my sine. Okay. So we note it down as cosine, but once again, g of x on the inside, so root k m t plus constant, and then this once again is equal to our function from the very beginning, t plus constant, like so. There we go. We have taken our first derivative out. Now we need to take the derivative again, because we still have a derivative. This time we're going to get a whole bunch of rules, and honestly I should have been using the paper a lot more wisely, because this is going to be a bit cramped. Because what do we get? Well, the derivative of this right here. We have a couple of rules at play. First of all, the summation rule. The derivative of this plus the derivative of this. The derivative of a constant once again is 0. The derivative of this is our x to the power of 1 from before, this right here, which means this is just root k of m, like so. Then right here we have a product rule, because we're taking the derivative of this entire thing, and this is one of our functions, this is the other, which means we need to take the product rule. What would the product rule here be? Well, since this isn't multiplied by the x, its derivative would actually be just 0. Once again, it's a constant, and it just so happens that, or lucky stars, what we get is the same thing again, root km cosine of root kmt plus this right here, except not the cosine, only minus sine at this point because we have taken a derivative, is equal to sine root km plus v, like so. And then this minus and this minus cancel each other out. This and this come together to eliminate the square root because it's a square. And then this and this come together to cancel each other out into a 1. And what we get is sine of root kmt plus this right here is equal to sine root km plus this right here, just like so. We get an equality, which means our equation has been solved. That was really messy. I'll need to make a special animation just for this because I'm not satisfied with it. That was way too messy. At times, yeah. Yeah. The neat part is all of this is genuinely stemmed from this single equation. MA is equal to minus KX. This, we had no information more than this. It depends. I would say, I get what you mean. I would say that just applies to differential equations. That's because differential equations are... a piece of paper, simply because that will give me a little bit more space to play with. No, because this one I'm using for recording, this one I'm just using for random notes. So basically, the reason why differential equations are such a mess is because when you're solving a normal equation, when you're trying to get a number, right, there is a kind of algorithmic way to do it. You know, you divide both sides by 3, you do one thing, you do another. When it comes to differential equations, what's annoying is that you're trying to guess what the function is, which gives you like, hold on, my sink is being a little attention seeker, which means that you're getting so many more possibilities. This paper doesn't have any more space either. I'm running out of paper. Oh, that would work. Splendid. This will work really nicely. Right here, at least half of it is paper. Then I'll be complete. These are the two things I'm missing in life. So basically, when you have some kind of differential equation, the reason why it's so annoying is, so, I don't know, when partial are even worse, like d3 dh3 of f of h is equal to something like 1 plus pi by, and even for even better measure, let's take an integral of f of h, because why not, from 0 to h. Well, actually no, because I already used, well, this will be t and then dt, something like that. The problem there is that, first of all, there's no algorithmic way to solve it, as in you need to figure it out on your own. There is no way to keep moving closer to the answer. You just need to figure out just how to do it in a creative way every single time. And second of all, consider how many possible answers there are. When you have some kind of x is equal to y, then you have an uncountably infinite amount of possibilities here. That's because for each, you basically have r amount of answers. That's your infinity of answers. That's how many you have. Right here, however, when you have these functions, you have there is a certain limit on the fact that they have to be continuous in order for it to work with derivatives, etc., etc. But still, you can imagine it as a plane where each one of points on the plane has its own r. So it's kind of like r to infinity possible answers. I'm saying kind of because, yeah, there is the requirement that they need to be continuous, basically, or analytic. I do think that's what it's called. But that's roughly how close you are. So all of this, not only is there no sure way to solve them, at the same time, there are so many possibilities for what the answer could be. And that's why you can just blow up from a simple, really simple MA equals minus KX. It can just blow up and evolve into this because there's just so much information in there. Alright. It actually does get pretty fun later on.
I mean, yeah, I believe you. Equations are always fun.
But that's only one
Also
aspect.
high complex spinning, by the way.
Oh, high complex plane as well, yes. But that's only one aspect of mathematics. I would say that that's more like theoretical physics kind of mathematics, because in actual pure mathematics you usually don't even see equations, you just have logical statements. And that just requires you to be truly insane, because then you need to logically think about things that don't even have like an analogy or a concept that defines it or a way to think about them. It's just insanity. Do you remember the brief example you said you didn't use force doing that, but you technically P dot is a force? Hold on. Technically P dot is a force. No, I don't think it is. I think I know what you're referring to, and I don't think it is. I think what you're referring to is this right here, P dot. P dot equals force. It doesn't really. I don't think it does. Because this is canonical momentum, and I'm pretty certain that time derivative of momentum equals force only works for classical momentum, not canonical. You have to realize that this right here momentum is defined in relation to the Lagrangian. I don't understand what that means. A way to get to the chain rule, as in like you can solve any differential equation using a chain rule, or do you mean like there is a logical way to get the chain rule? Because I mean, yeah, there is a logical way to get the chain rule, otherwise I wouldn't have been able to do this. I'm pleased with it because I actually solved the harmonic oscillator on my own when I was on the bus. I didn't look up anything. And that's why I'm pleased with it. I forgot that. Yeah, what you have to... it is my drunk science notebook, so this kids knows, yeah. But what you have to remember, complex thing, is that if you are talking about the Lagrangian Hamiltonian formalism, there is no notion of a force. That doesn't exist. As in, you can have things which would have the... you can have things that are similar to a force, as in they are described by the same units, as in they have the same characters, but they're not forces. That's because force on its own is a pretty flawed concept when you are trying to describe more complicated, more elaborate, more precise systems. Physics is really like energy, so everything is... They always like describing everything in terms of just energy. Hamiltonian, Lagrangian. They are both just... They're both just energies. Why? You should look into that then. I will say, Macaroni, that you do certainly like a very specific kind of abstract thinking, and I think you've just been brainwashed by big society trademark to think that that's philosophy, when in reality that's just theoretical physics. I will never... I would really recommend it because I genuinely think you would like it. It is a really difficult thing to get into simply because, well, there is just like a lot, obviously. It's almost as bad as mathematics when it comes to getting into, simply because there are just so many abstract concepts. But I genuinely think that that's something you would enjoy, simply because it really is just thinking in its most like purest form, where you genuinely, when you're doing theoretical physics, you sit down to think, and your thinking is actually just like really making a difference in the process that you're working with. Will never forget when I went to the Leiden Uni and I just went in there and I genuinely saw a whole like department of the university, a whole wing of a building that was just dedicated as space for people to think effectively. There were like offices, there were like, classrooms, stuff like that. But they just really went there to think. That's it. There was another building next door which was more experimentalists, and over there they had all these crazy machines. They had 3D printers. They had a whole bunch of circuitry. They were building stuff like that. Whereas the theoretical physics was just like rooms to think, and it was hilarious to me. Just whiteboards. Oh, you can't hear. There we go. Sorry about that.
Yelling Eureka and running over to the practical physics rooms to test out an idea.
I mean, yeah. That does, I imagine, happen at times. I mean, Remco had this thing where he recently just tied together relativity to quantum mechanics. I think general relativity to quantum mechanics, more specifically. And that was certainly a eureka kind of moment. Yeah, I love these. These are like crack, but just better. Yesterday, when we were trying to figure out the Maxwell's equations, the moment when the del cross clicked in my head was incredible. I keep switching between on and off, but there we go. It was so incredible. Because it all of a sudden made sense. It makes sense why it's curling the way it's curling. The curl operator, is what I should call it. Okay, well that's enough theoretical physics for now. Time to get a bit practical.
Good lord. And it went back to the computer.
Yeah. I do want to make
Right,
another physics stream today, because yesterday I had a lot of fun, but to summarize, I genuinely do believe you would have a lot of fun with theoretical physics.
I'm gonna write that down so I don't forget it.
Because also with personality-wise, you do have a very love of thinking and disdain of applications, which is just such a quintessential vibe. Right, and how are we doing? Oh yeah. Oh, I can feel the caffeine working. I haven't been drinking all that much in the past 2 weeks, and I forgot how nice it is. Alright, let's get back to hitting a cube with a car.
Make it doing psychoactive drugs.
We live in a society in which Adderall requires a prescription. Because this life is a prison. Oh yes, hi, we have this molecule which makes you more concentrated, energized, it makes you stronger, it makes you faster, it improves your reflexes. Oh, do you have a runny nose? Yeah, it can fix that. All of these things. But no, you need a prescription for it. Because this life is a prison.
I mean, isn't it a amphetamine?
It is, yeah. But it's not...
Which is addictive.
It's not that addictive.
So it's addictive like caffeine.
I mean, okay, I don't know how addictive it is, but I know it's not that addictive. And meth is really addictive and destructive.
Yeah.
But
and
amphetamine is...
Adderall is an amphetamine, which is methamphetamine, but without the meth.
Oh, hold on. Sorry, I missed out on a couple. It also it treats ADHD, narcolepsy, obesity, treats binge eating disorder. Because it also does way more, obviously.
Adderall. How addictive is it? Let's see. It's highly addictive, especially when misused.
Yeah, but that's for recreational use. I don't care. My use isn't recreational, it's very professional. Or it would be.
So like cocaine with business people.
Yeah, actually, you know, no, that's pretty on the nose, yeah. I need to understand the
I just
difference.
see patterns.
I need to understand the difference between canonical momentum and classical momentum. Alright, allow me, because I can explain it easily. I thought we were done with the camera, but we are very much never done with the camera. We will never be done. Think about it this way. I'm going to explain to you the difference between... vitamin sponsor. I wish. Because I imagine if I get a sponsor, I would get a little bit of the product. So, think about it this way. You have classical mechanics. So we have the easy stuff, the simple stuff. In there you have forces. You have a ball. You want the ball to move. What do? You apply a force on it. You push it. You push it, the ball is moving. Then it keeps moving, keeps moving, keeps moving. You want to stop it from moving. What do? You apply the force back. And then it stops.
Yes.
Yeah, simple, trivial, intuitive. What is the problem there? The problem is that forces are generally pretty tedious. That's because as long as the force is applying, then the acceleration happens. It's a concept that's a bit discrete on one hand. On the other hand, it's really difficult to put into more complex systems. On the third hand, it's very much doesn't click with differential equations. It's just a bit of a mess. So, what is the solution of physics? Energy. Focus way more on energy, less on forces, which means you have your ball. It's stationary, its kinetic energy is zero, it isn't moving. But there is some potential energy that can be put into it. It will be something like a Q, why not? Why not, might as well Q. What do you...
I wouldn't call it potential energy because, I don't know.
It's potential because it's basically like kinetic energy and everything else. Like potential can be broken down in so many things, but it's just genuinely everything that isn't kinetic. But yeah, so what do if you want the ball to start moving? Move a little bit of energy over. You move it over, it starts moving. And it keeps moving continuously. What do you need to do in order to make it stop? Move the energy back. Simple as it could be. The reason why it's better is because then you can think of energy, both the potential and continuous. You can think of them as just continuous graphs like so. Or rather with functions, not graphs obviously. Which makes the formalism a fair bit more powerful because it makes it more general. The reason why it's also nice is because the potential energy, well, kinetic energy is very specific, isn't it? It is px dot by 2. That's kinetic energy. Potential energy is just Vx. As I mentioned, it's everything else. Which means that if you describe everything in terms of just energies, then all you need to do in order to extend that system is just define the things that you're extending it to in terms of energies as well. So you basically like separate off your process of creating physics into two parts. First of all, the mechanics using the energy, and second of all, describing the processes using energy. The reason why it's useful is because they work independent of each other. So if you have a really good description of mechanics, then if you discover a new interaction, or if you try to reformalize an interaction, or combine them, or whatever, all you need to do is take this new system, you need to describe it in terms of potential energy, and then they combine on their own. That's the idea. So, in this scenario, if you describe something that has kinetic and potential energy, then I could ask you a question. Is this ball affected by electromagnetic interaction? Is it affected by gravity? Is it affected by something else entirely? I could ask all these questions, but the answer is that's irrelevant because it doesn't matter. It will behave in the exact same way no matter what, which is what makes it so powerful. If you return to forces, however, F is equal to ma. They are significantly more restricted because you need to define a separate force for everything. and then there isn't like a singular nice way to combine all of them together. Because forces also don't have to be continuous, and so on and so forth. The point is just annoying to deal with. Energy isn't though. Energy is really nice. I hope.
Energy is really, really practical to think in, because I think I've been thinking in energy all the time.
Oh, that would be good. That would be good.
When I say I have a clear-cut an intuitive understanding of forces, I think I was talking about energy.
I'll be honest, it is, in my head it's a bit messy, because I don't quite understand energy all that well, simply because, well, I do understand it decent, but not great, simply because I know for a fact there's some kind of fundamental reason why we separate them off into kinetic and potential. But in my head, I just simply don't know that reason, because that's like really far in the distance. So in my head, I do always just separate them as kinetic and everything else, because that's it. Because potential encapsulates so many things. I will need to ask actually Remco about that next time we chat. Is there some kind of deep reason why it's kinetic and potential?
Yeah, that makes sense, your explanation.
Yeah, because I mean, to be fair, that's not. I don't want to sit here and pretend as I'm an expert, because I'm not. What I've mentioned so far is pretty simple stuff. I mean, I'm just giving you a contrast for classical mechanics versus not classical. And classical is genuinely as simple as it can get. It makes sense, but it is not the difference between canonical and classical momenta. No, I mean, that is the difference, because the classical momentum is created for the purposes of a force, whilst canonical momentum is created for the purposes of energy. As in, canonical momentum is described based on the Lagrangian. This. And more specifically, it's a partial derivative of Lagrangian in relation to velocity, which gives you basically a derivative of the energy right here. So if you want to think about it some kind of way, then would this be a good idea? Yeah, you can think about it this way. Classical force is just P dot. As in, it tells you MA, right, is equal to mx double dot, which is equal to mx dot, and then all of that dotted, which is equal to P dot. I hope this should be simple enough. So the force with the classical momentum acts this way. However, you can have different momenta in different scenarios that behave differently. Once again, the example that Remco gave to me when he was teaching me this was the momentum of mx dot plus q something that happens for particles in a field, in an electrical field with charge, basically. I think it was qa, but don't quote me on this because I'm not certain exactly. The point here being that classical momentum is described to operate with forces like so. Canonical momentum is defined this way because that allows it to operate based on the energy. I'm thinking, because I see that I'm explaining it the same exact way over and over, so I'm just thinking if there's maybe a clear, better example I could give you.
I think I missed a couple of lectures because I don't know what P dot means.
Dot is just derivative in relation to time. So, so x is position, x dot is, oh sorry.
Position over time.
Yeah, x is position. Once again, I did it with a dot instantly. Okay, x dot is velocity, x double dot is acceleration, x triple dot is the jerk, x quad dot is the snap, etc., etc. It's when I used to complain about it a lot, but now I really do get it, which is that I used to complain about physics notation, or lack thereof rather, but now I get it, because when you're writing out equations all day, then simplifying the process of writing out a derivative this way into just a simple dot saves you so much time. So yeah, so P dot would be just basically how the momentum is changing, which makes sense as a description of a force. No, I don't know if there is a better way for me to explain it. Hold on. I will need to get back to you on that complex thing because I don't have. Or you could just wait. You could just wait until. You could just wait until the Lagrangian formalism video because over there I'll explain it better, and that will be the next harmonic oscillator video after this one. So.
Sure, I guess so.
It'll be pretty soon.
I mean, I gotta watch your mathematics series again because
My math series isn't. I don't have all that many great ones. I really need to make some better maths videos.
yeah, but the latest one because I'm not really up to date on that one.
Oh, those. They're not bad. The derivatives video is a bit simple, but the partial derivatives video has a nice example at the end.
Like the ones after I'm starting a charity.
Yep.
I think I haven't watched 3 of those. Damn. Or 4.
Okay. I really hope I can finish this. I would need to rush it. Well, not rush it, only work pretty damn hard, but I would like to try to finish this video today. Okay. Right. No, we needed to have custom. Yeah, no, we needed to have custom stuff anyway. It's fine. Always worried I'm gonna misspell harmonic oscillator in the video about the harmonic oscillator. Because what do you mean it has 2 L's? Okay. feels good to finally be able to do physics. Not just the theory, but actually being able to use it.
Insert feels good man meme here.
Thanks, Jamie. It just hit me that Jamie is just the repeated Jarvis meme.
True. Jarvis.
It was so funny to me when I posted in the Giver channel that like in Poland, near where I live, there was minus 17 degrees weather. And then Caper just replied to it, "Ad ban it. Is this real?"
Absolute cinema. Absolute cinnamon.
I need to add the ad ban. I need to after I'm finished the video, I need to implement ban it into the website. Just that I can do ad ban it. Is this real? Why does it look like such another trash? Well, okay, it's not as bad as it could have been, but not great either. I'll remove all of these. That was value 10. Oh, that's strong. This one needs. Okay. Yeah, then we don't need a 10, we can do a 3. Okay. Oh, I'm wondering why I'm so exhausted, and I realised I still have the industrial light blasting in my face. Oh, finally, darkness, jeez. That was rough.
Doesn't darkness make you more exhausted?
No, the light is worse. Because they are the
Alright.
proper like camera lights that I'm turning them on whenever I want to write on the table, because then it looks better, but... Oh... Okay, let's try coordinates. Take them off. Oh, you cheeky bugger. So. Yeah. why not clever we do it? Which is them off. Multiply 1. Yes. There we go. There we go. Because then if we plug this into the X like so, if I'm not mistaken, this should lead to every 40 frames either perfect oscillation or I messed up the math. Okay, no, it does look to be roughly perfect. The problem is that this is perfect oscillation. Beautiful. Yep, splendid.
Splendid.
Splendid indeed. There we go. Okay. Now let's leave the multiplication be. Let's do this like on 1. 0 right here though. And we're going to have 10. We're going to have 0. There. Should be fine. There we go. Wait, hold on. So this is the height. Is minus 17 really? Minus 17. Really just 1 Fahrenheit, damn. Okay. Let me have a thunk then. should be fine. Oh, why does it take that long? Ah, whatever. I was at one in the rush. I have all the animations I need to do. Let's reverse it and let's shorten it.
So what you're saying is that I should study theoretical physics when I get my... how's it called? My thingy. When I'm done with my... the thing you need to go to college in Austria and Germany. Interesting.
I'm saying I think you'd like it.
So you're saying I should do it? Interesting. Something practical, yeah, Matura. But I didn't know the English word. But
You know what's funny? It's called the same thing in Poland.
no fucking way.
I genuinely I wasn't aware that it's called the same thing in different countries.
Me neither.
Is it like a European standard? Now I'm curious.
No, because Germany has Abitur.
Because it's only reasonable that Austria and Poland has the same word for it, whilst Austria and Germany has a different one. That only makes sense.
Certainly.
Albania, Austria, Bosnia-Herzegovina, Bulgaria, Croatia, Czech Republic, Hungary, Italy, Kosovo, Liechtenstein, Montenegro, North Macedonia, Poland, Serbia, Slovakia, Slovenia, Switzerland and Ukraine.
All have Matura.
Yeah. That's an odd assortment.
Yep.
It ranges everywhere from Czech to Australia.
Yep. Sure does. I would love to live in Liechtenstein.
Isn't that a place that has free public transport?
I don't know, but they have a party every year where... But the king throws a party every year where every citizen is invited.
It's not gonna lie, based on our brief exchange here, it really does sound like as if it's a brutal dictatorship with some propaganda that we're both falling for. Oh, that place.
The how's it called? The citizens really like that guy.
Oh yeah, well, you know the benevolent king throws a party every year where every peasant is invited to join in. They have free public transport as well. That's a great place.
Have free public transport?
I thought it was Liechtenstein. I could be wrong. Hold on. Let me see. Did I misspell it? Maybe. Public transport.
Oh, yeah, it does. Under specific conditions. National holidays, overnight guests. Some participating hotels, some classes. And ticketless travel is available via the fare IQ.
I really do believe there should be a European standard for just tickets. Because it bothers me so much. Both Austria and Poland wanted to differentiate themselves from Germany after what happened roughly 80 years ago. Yeah, but you know, linguistics-wise, I would say Austria is like a little bit closer to Germany rather than Poland is to Austria.
A little bit. It's not that
a little
huge
bit.
of a deal, but like
A tiny bit.
a wee bit.
Figure is asking. Yeah, please. Sorry. Right.
Figure 9, technically no, I could. But I could apply to acquire it, but I'm too lazy for that. Straight up, so I'll make an evening course. Which means I'll have to probably... how's it called? I don't know. Which probably means I'll have to... don't have the advantage, but I can study in Germany then. Yeah, Abendschule. Wasn't searching for that word though. Evening course was... but thanks. Just... yeah, it was, which means I can't do it over 5 years then, but I can, for each module taking up 1 year. But I can study in Germany then. Pretty sure. Yep, that is one hell of a word. Studienberechtigungsprüfung. Certainly is. Also, make it, you should try saying Oachkatzelschwaf.
You just said that word to me and it instantly went out of my mind. That's how it sounded like it was exclusively vowels.
Oachkatzelschwaf.
Oh, there's a K in there. At least I'm guessing. Oh, God.
It's in VC chat. It's dialect.
Oh, as if that's going to help me out. Hold on. Getting bigger text for myself. No, yeah, again, based on just hearing, figure, okay. Oh, Kassenschwab. No, it's awful. Okay, I would just like to mention, in the end, in the middle, there is TZLSCHW.
Yep.
I think there should be some kind of rule where this kind of combination of letters isn't allowed.
Quatzelschwi. Quatzelschwi. Damn.
That's too many consonants in a row.
You're like the "can I have a vowel" meme.
I cannot afford flame post in the chemist channel.
What?
I should look at the game, I can't put the words, but it's just hilarious. The picture of like genuine proper scientist doing genuine proper scientific research and just shit posting about it is just messing with me.
Ah, wire.
There's like a genuine real scientist doing real scientific research with some really specialized equipment, and I just find it hilarious.
Maybe one day they become a theoretical physicist and I'll just sit in some room and think and get paid for it. My God, that would be the dream job.
Yeah, it's quite something, isn't it?
Mm-hmm. Because I don't want to study philosophy.
Understandable. Yeah, you don't have to tell me that. I can sympathize.
Even though I like it, I don't want to study it because what do I gain from it?
I both don't like it and don't want to study it.
Yeah. Klatschen to fill around with your fingers. Huh. Interesting. You should, like, that sounds like something I would do. Also on dates it might sound really good. Yeah, what do you do? I'm a theoretical physicist.
I mean, yeah.
What people imagine me being like, doing a whole lot of math equations and writing stuff down on a chalkboard and talking to people who say yes, interesting. But how could we apply this to ... what it actually is, sitting in a room and...
I mean, no, the first thing you described, that's genuinely what it is like, yeah.
Oh.
That's genuinely what it would be like. Except without the question of how would we apply this to, because that's disgusting. Come on, that's not theoretical physics.
True.
Leave your experimentalist bullshit in the engineering department. We're here to
Wait,
do...
so it's not like one guy just randomly jumping up, yelling Eureka and running off to the practical part of the building?
No. I mean, you do jump up, you do yell Eureka, but you don't run to the practical part of the building. What are they gonna do?
You write an email to the practical part of the building.
I mean, it depends, I suppose, what kind of theoretical physics you're dealing with, because my view of theoretical physics is a fair bit biased, considering how the one theoretical physicist I know is Remco. And, like, Remco is dealing with stuff that experimentalists absolutely cannot verify, because he's, like, dealing with quantum mechanics of black holes, basically. What are experimentalists gonna do with that?
Create a black... Okay, so what we're gonna do
hole?
is, we're gonna break into CERN, and we're gonna create a black hole, and then we're gonna confirm Remco's theories.
Yeah, exactly.
Or not confirm them.
So it's more like you know, sitting silently in deep contemplation with can you hear the music playing in the background, and then
Nope.
And then as the crescendo happens, as it all escalates, all of a sudden you spring up, go to the whiteboard and you start writing, or the blackboard actually, sorry, theoretical business. You start writing, and then when it all culminates, then you step back for a second. The whiteboard, the blackboard is full, and then there's like a big equation in the middle that solves whatever it is you're trying to solve.
And then you're standing there, oh my god.
Yeah, like, dear God, and then you run out because of the discovery.
Yep, and have to tell everybody about it.
Yes.
And everybody just says, oh my god, you figured it out. How did you do that?
Yeah, and then, exactly. And then after a while you just meet with Einstein next to a lake and just talk about the end of the world, that sort of thing.
Yep.
The theoretical physics
That actually
experience.
was something I thought about. So the people in the Manhattan Project, they were theoretical physicists.
Well, not...
Turned practical.
No, not quite, because the Manhattan Project had like a couple of divisions.
Alright.
Oppenheimer was the head, and Oppenheimer was the theoretical physicist. Yes, but they did have a significant amount of. They were varied. There was a lot of very different kinds of people.
Alright. Cover your how's it called? Interesting statement.
Yeah, I was about to say is that you were looking for a word, and is my sync helping?
Yes, it is very helpful.
It does sound like someone trying to pronounce a German word, to be fair.
No fucking way.
Oh, but yeah, you had the question before my sync so rudely interrupted.
Like covering your weaknesses.
Yeah, I mean the thing that was so funny to me when I was watching Oppenheimer, the movie, is that Oppenheimer, obviously, like it's a real story, but at the same time, it's not as if I'm a history buff, so I don't actually know all that much about Manhattan Project. But most of what I know about it is from the movie. What I found so hilarious that Oppenheimer was a theoretical physicist, but the Manhattan Project on its own was way more of an engineering challenge, because the entire motivation for the project was the fact that theoretical physics was completed for it, or like at least it was proven. And so to me it's just really funny that the head guy was from theoretical physics when in reality most of it was just engineering issue. But the other one, the not atomic, only the fission bomb, right? I think it was fission. That one was theoretical physics at the time.
Huh. Sometimes I feel bad about asking you questions live on stream when you're working, but then I remember I pay you $60 a month.
Don't feel bad about it. It's my decision to stream anyway.
Yeah, it's your decision to have a Patreon and have on the $60 a month tier have might feature exclusive explanations from me tier.
Is that still there? Well, I suppose.
Pretty sure.
On accident, on accident I checked that box.
Yep.
But a kilogram of shroomies is they for the cheap. Good for you. It's really expensive. Really expensive buckets.
Shrooms sure expensive, yes. Let's see if it's still there. Don't think so. I was remembering the past, as one does. No, it's in the first paragraph.
Oh, wasn't it in the first paragraph?
Of philanthropist.
Oh,
Personal
yeah.
explanations to my videos.
Well, check that box on accident. Glad to glad to do it.
I mean, hey, I pay you $60 a month, so I
Yeah.
don't feel bad.
Yeah, good. You really shouldn't feel bad about this regardless, anyway. You asked pretty good questions.
Really? Damn.
Okay. So.
Well, my friends also call me the question asker.
Really rolls of the tongue, doesn't it?
Just like the fax machine. Because I only spit facts.
Fax machine is pretty funny.
And the fax machine. Alright, also not trying to get into biology real quick, but like, what makes mushrooms different from plants again?
Oh, I don't know that. I mean, it's like fungi versus flora, isn't it? I think the mushrooms are more ancient, more similar to, but actually not fungi. I have no idea.
Pretty sure. Yeah, they probably are more mycelium and not being able uh to make uh not having chloroform, not chloroform. Ah,
They don't photosynthesize.
also
They have
how does it work and
spores.
communicate. Yeah, no photosynthesis.
And they are actually more closely related to animals than to plants.
Yeah, that
That makes sense, surprisingly.
even though they have a symbiotic relationship with plants sometimes. Trees, to be more specific. Why can't fungi have a symbiotic relationship with humans? I mean, technically they do, but like... Figure 9, I was also asking that question, but I didn't ask it. So Lichen is also its own thing. Interesting. A kilo of magic mushrooms.
I would
That would be
never,
something.
I would never in my life eat that amount of psychedelics. Well, never say never, you know.
That would be a weekend plan.
Pleasant afternoon.
Like you have a photosynthesis side and a shadowy side. It's like the light and dark side of the force. Algae provide sugars for the mycelium. I'm learning so much in here. Trying to also get head pats and called a good boy. Oh my god. You had me at head pats.
You had me at return. Dorothy, do you know where one could apply for this algae position?
What? Where?
This figure is asking. Figure,
Oh,
if...
on top.
Listen, Figure, if you want headbutts and to be called a good boy, we can make it happen.
Make it? Is that a make it reference?
It always is.
Dear Lord.
That's curious. Why did I save it to derivatives? Why am I questioning myself? You know what? Fair point. You can make it happen, one must make it like that. Well, headpads are a bit more difficult, but you are a good boy.
Grown man, by the way.
Oh, I'm sorry, so we can't say that anymore?
Nope.
Yeah, that's what happens to the tolerant left when you someone.
Yep.
I will defend my right. My right to let good boys know that they've been good boys. It's not only my right, it's my responsibility.
Of course.
Well, you kind of, not gonna lie, Figure, you've kind of ruined it a bit.
Yep. Just keep it subtle next time.
Middle East, am I right? Whoa!
What about the Middle East?
Why does Java want make changes on my device? No. Oh, you wanted to update Java. Well, now is not the time. I'm streaming. Update yourself later. My Clash of Clans is happy. Good. I would upload as a shitpost, like, make it calling you a good boy ASMR, but after this reaction, I'm hesitant.
Yep, understandable.
Depends on money, right? I suppose. So, listen, the charity needs money, what can I say? I'm not above doing that.
So true. Just like Markiplier.
I mean, listen. Make it Tasteful Nudes calendar. It could happen. All I'm saying is that if charity one day were to develop, right, grow in size, that could happen. So if you all want to see that, then I suggest you better support the charity.
Might gift that to my sister.
Oh, that's... Well, you gave me the book. And I know there's one YouTuber who has been sponsored by the book company. He recently released a certain literary work of his own.
Exactly.
I've seen you got called a cute mouse by a study called a female. I really hope that when you got called a cute mouse, you didn't reply by saying, I have a new jerk-off material now. Because I will be honest with you, that's not a great response.
True.
Right, I'm working on a video. I did fortunately not do that. Good, I'm proud of you. I'm proud of you for the restraint. There's also a great term of endearment in gay culture. Is it really? I've never heard of it.
Because you're not German or Austrian or in a German-speaking country.
I suppose that's fair.
Right, also, the run was horrible. Just to update you guys.
Oh yeah, because you drank the white to go for a run.
No. Not because I drank the white.
No, no, I was saying that you drank
right,
the white to go
gotcha.
the run, and then yeah, why was it horrible?
Because it's running. Unlike David Goggins, he also hates running. Even though that's the only thing he's known for.
I need for a video. I need like a random, just random clips of movement, and I just found this one. I just find it hilarious. Just one of many scientific animations I have saved.
Not seeing it. Maybe.
Try send it into live voice chat.
Oh, gotcha. Bro is not balling.
It's absolutely perfect.
switch back to spotted. Where?
Hi, Raj, yeah. Hi. On the video, I think.
Hi, Ash. Where?
Depending on the circles you're in, even horror can be a time of affliction. Yeah, I once was talking to a trans person who just referred themselves by saying very tranny when they just felt proud of the makeup they've done. I've also been called a reassurance warrior by them, which I also like. I haven't created the whiteboard since. Yeah, that's good. This you can't, Theo. I'm sorry, you can't. You gotta follow the bureaucratic process.
So true.
I spent 1.5 hours preparing just one goddamn level. Oof, mathematics. Or physics, I suppose. You're in the grey area. My goodness, that video had some really good animations. Just really, look at this. I have truly outdone myself there. That is incredible. I mean, I
think it's stroking himself.
It's not okay. It's not a difficult animation to make, but it does look really good. Don't mind the dogs dying in the background. That's just something that happens in my neighborhood. Isn't queer a slur once? Almost every single, like genuinely, almost every single slur used against LGBT people is a compliment, depending on the context. You can pick every. I would actually challenge you to find a queer slur that I haven't heard being used as a compliment yet, because every single one I've heard being used as a compliment, which I think is really nice. You remember Twink being a sofa? I don't. Really?
Wink.
DPS Twink versus Tank Bear. The Bruiser Otter as well. One of my favorite, one of the greatest moments on stream was when I was like, wait, hold on, otters and bears are animals. Is Twink an animal? And I just looked up Twink. It isn't. There is no animal called the twink, and when you look up twink, you do in fact get pictures of men.
Great heavens.
Great heavens is an appropriate reaction, I would say. There we go.
I will be right back.
Okay.
Just have. Yep.
No element. Absolutely no element. Okay. There we go. Well, actually, no, I'm not yet. Yeah, I am an idiot. That's not what we need. We need something different. We need a harmonic oscillator that's going to represent the classical harmonic oscillator. So now here's where we need to get into the geometry nodes surrounding it. Well, roughly at least. Right here we're going to have classical. For which we like the arrows, which we can get from the partial derivatives. By copying this. Oh, there's so many things I need to do for the website. I keep trying to focus on one piece of work, but there's always so much more. It's really difficult. Okay. We're going to have this arrow be green, then we're going to have another arrow which will be orange.
Alright, what did I miss?
Not much. Nothing really. In fact.
Alright. Alright.
so we're going to handle it like so. And then we want, as always, the oscillation. There we go. And then sine goes in here. This gives us oscillation already, brilliant. But what we want is we want value of a frame, and math divide by 40. Fraction multiply by 2 times by. Or actually, I think yeah, because this is meant to represent forces. Oh, that was brilliant. That's
Force.
really good. Why is phi so nice to look at? Well, it's mystical. Ever changing, it glows, it's warm. It's basically everything that someone can find interesting. That's not bad. Really close. Really, really close. I don't even remember what video this is from. Maybe a bit. I like this. I like this a lot. Okay. This is really good, I have to say. I know that the image of me just watching my own video and saying this is really good is a bit icky, but the truth is that when it comes to most videos, at this point of the video making process, I usually hate them. So if it's good, that means...
It might get a lot of views.
Well, I don't know if it's actually gonna get a lot of views because the topic is... If you're a physicist, then you will find the topic obvious, and if you're not, then you won't know why it's interesting. I think it falls that gap, but oh well. It's not about the money, it's about sending a message.
I mean, principally, yeah. Kind of.
I mean, objectively so, I would even say.
Mm-hmm. Because, like, why are you even doing it? Because you are just doing it out of love for the game at this point.
Exactly. Life does get a fair bit easier when you just say fuck it. Chuck it in the fucking bucket.
All.
Exactly. Fuck it, we ball. It becomes
Should
much
call it
stronger.
Discord bot, fuck it.
No, we do already have one of those bots, but that bot is our main source of revenue, to be completely frank and honest with you.
What? I don't get it.
Sex joke.
Oh, gotcha. I may have Austin. But I don't know.
Fuck it, the ball becomes a much more powerful statement once you account for the pre-existing axiom that ball is life. Because the latter effectively transforms the former into fuck it, we live. And what message could be more powerful than convincing a man to persist at all cost? Right, we need a graph, is what we need. If I paste it in, that still pastes the play. Yes, that's good, that is what we need, yeah. Once again, we need the arrows.
Make it equals fuck it.
That's going to be a bit more annoying, but only a bit, so it should be fine. This one's still going. harmonic oscillator. Mickey, have you ever heard of the queer slur transformer, heard in a positive way? I have. I've even seen memes about it shared between trans people. I've also seen puns about it as well. I had a dilemma actually a while back, which is, should asexual people be included as part of the LGBT community?
Interesting.
Why not? Well, I'll be honest, I don't have any like concrete argument, it just doesn't feel right.
Yeah, because it's about sexuality, and asexual isn't really technically.
Asexual people at a queer hangout just feel like it feels like if you're at a Halloween party and you're the only person who's not dressed up. That's the only way I can describe it. Still is sexuality. Well, I mean, yeah, but so is straight. But broadly, most people in the queer community don't consider straight people to be part of it. Because straight people are not the minority. That is the reason. I haven't thought of that actually. Hope I spelled this correctly. I did. Cheers.
Yours just reminds me of Patches from Dark Souls. No, from Elden Ring specifically. because he always says cheers for that or something like that. No, that wasn't the right tone fall. Cheers for that.
Whenever I say it, what reminds me of is just Butcher from The Boys saying "Cheers, love."
Interesting.
Having a safe space for non-straight people is important. Yeah, but at the same time, I've never really seen any hatred against asexual. I think asexual is like the... Okay, I wouldn't say easiest thing to be, but I would say the least discriminated thing to be.
Pretty much, because
Who has ever...
you just don't want to fuck people.
Yeah, exactly. Who has... I've never seen anyone hate on asexual people. To be fair, maybe I don't tend to hang around in the hateful, like, recesses of the internet anymore.
Yeah, that's what I'm for.
So, exactly, exactly, Macron is my expert for that. But I've just never seen it. How should we do it? We can multiply it by... No. Divide it by 2, add 1. Add 0.5, yes. Gives us 0, 1, which means this will oscillate, like so. Beautiful, but that's not really what we want. What we want is we want it to oscillate in... So, how many events have you been within queer and gay culture? I haven't, because I'm genuinely not... I've never really been included to any kind of culture that heavily. I mean, well, I've never been in any gay or queer events. I do know a lot of gay and queer people, considering how most of my community is queer/gay. But that's just simply because of the overlap between that and STEM. Nicky, I think about it like this. Straight is kinetic energy and the rest is potential energy. No, but that's the pickle, because Ace, genuinely, the analogy of like the only person not dressed up at a Halloween party is, I feel like, spot on for what I'm trying to describe. That's the only way I can describe it. Like, in my head, that's how I picture it. That's what it feels like.
Yeah, it makes sense.
No, we don't. We need... No, we do need two separate things. But we can have them be like this. Uh-oh. Okay, what's the problem now? There's a weird subset of straight passing gays that's misogynistic and just outer problematic, and boy, let me tell you, I can read them. Ring with them is a pain in the ass. What kind? This glitch again. so that's fine. Stoning attribute brightness, free color of color. There we go, and then we can make group it. Can we go into negatives? It can, that's perfect. Because then we're going to have drawn geometry, like this. And right. Two. Right, and so then we want this is kinetic minus potential. And then this is effectively what we want. Then we can scale this down to be 0.4, for example, and then we can there we go. go. Now what we'll need is oh, this is going to be quite annoying, I just realized, because here's what we'll need curve 9. And then what? Well, good question. Hi, Detanza. Hi. How's your day going? Unfortunately, really busy. I'm trying to finish the video just so that I can have a little bit of time to actually do some other work. Behind on absolutely everything. Oh yes, of course. This will not do. We actually want to move it by like this, which means right here we need to subtract 0.5. There we go. This is more accurate. And then even better, I would like to scale it down by 0.8, I think. There we go. And then what we need to do is we need to do color bump and create the function that's not near to what I want. No, I need like something that doesn't show the points, but all of this does show the points. Which means that I would much rather need to come up with a different, more continuous function. Hi Adrian, hi. Funny thing, I was working on something in the last 4 weeks and may have missed the deadline by 2 minutes today. Oh, I'm really sorry to hear that. That is terrible. What were you working on? Are you feeling good enough for blended teaching? Are you exhausted? No level. I'm feeling good enough for it, don't worry, yeah. Even better, I'm rendering this in the background, so it should be... I hope it should be fine. I could have actually added a bit of brightness to it, because it's kind of hard to read. Yeah, you know what, I'm going to re-render this in fact. So even better. Multiply it by 7 or 6, let's do 10 even, and add Also, are they offset? Because I don't want them to be offset. They are. Well, I'll be damned. I've plugged them in backwards.
What?
The functions are not the way they're supposed to be. Sick of the animation.
Gotcha.
Oh no, wait, I'm an idiot as well, because this actually has to be multiplied by -1. There we go. One there. Alright, so actually rendering Remco. What do you mean? It's a Python-related project, but there was no one there except me, because trying to complete it in 4 years was because of very speed. But I almost made it, so that's something. I need to take a break at this, and you good luck to next. Well, you deserve a break then. Have a nice break. I'm really sorry about the deadline thing, but still, I'm glad you're being really strong about it, and that should be appreciated. Good for you. And you do deserve the break. All right, then Adrian, a question for you. Well, I suppose no. If we're going to do Blender, that should be pretty simple. All right. I'm going to open up a new instance, and we will. Here's what we're going to do. I'm going to teach you geometry nodes, because that is undeniably the most useful thing. Won't Remco be on screen the video? Yes, Remco will be. Well, in the meme, you know. This. My goodness, that's a handsome drawing. Right. So, geometry nodes. How do they work? First of all, you go to the right, you split the screen, you go to geometry node editor, and you create a new set of geometry nodes. Now, the way they work is you have these connections right here. These connections, which are your information. These lines are your information of different sorts. You can have green ones or teal ones, whichever one we prefer to call them, which are your geometry info. You also have gray ones for just floating point values. You have dark green for integers. You can have rotations, which are slightly purplish, pinkish. And you have vectors, which are purple. Vector, like this. You can have matrices, or we can have objects which are orange. You can have matrices which are between rotations and vectors, like they're also purplish, reddish kind of color, etc., etc. Different kinds of values that are represented with different colors. Now, the way geometry nodes work is they transform these values. You can imagine it like a filter. So, for example, we can have a transform node. What this does is it transforms geometry. So it takes in the geometry to be transformed. We're going to skip this for now because that's a bit more complicated. Right here, you have a transform, so where to move it, how to rotate it, how to scale it. So if we take this, move it 10 units to the right, scale it up by 5, and rotate it a bit on the y-axis, then there we go. This is what we get. The reason why this is what we get is because we started with this information. This information made its way to the transform node. Then inside the transform node it was transformed and we get new information. So that's the basic idea of geometry nodes. You can, for example, take in a join geometry node. Now what join geometry does is it joins geometry, it combines it. So we can take our original cube and the transform one like this, and we get both of them. That should be simple enough so far, I hope. I'm thinking if I should introduce the fields already, or if I should leave them for later. No, that's a pretty crucial step, but that's also can get quite confusing at times. That's clear. Okay, good. Then if that's clear, let me complicate this a bit for you. With something called instance on points. And then also mesh line, just for the sake of fundies. So what does instance on points does? Well, you plug in the points that you want to instance on, you plug in the instance, so the geometry you want to instance, and then you do this. And what this did is, this right here is a mesh line with 10 points on it. Am I doing something wrong? Because when I right click and I go to search for search transform, it doesn't find it. Shift A, and then transform. Shift A is just for adding a node. You need to be in geometry nodes though, because if you do Shift A right here, then you won't find the transform, you will find the triangle. Actually, would you find the triangle or is it from my add-ons? It might be from my add-ons. Not certain. You need to be in geometry nodes. And also not shader nodes, because shader nodes are also something we'll get to because they work in the exact same way except for shading instead of geometry. Okay, good. Then let's get to fields and instancing, because that's going to be a lot more tricky. Right here we have a mesh line made up of 10 points. On each point we instance a cube. Like so. What we get in return is 10 cubes, each one on one of the points. We can move the line about, and it moves the cubes. Like so. Simple as it could be. The interesting business happens when we get the index. Now, index, as you can see, it's dark green, which means it's an integer. However, what you may notice is that it's different from an integer because an integer has a rectangle, whilst an index has a diamond. And that is actually crucial. That's because each one of these points on this line, if we plug in integer somewhere, so for example, let's do it at 2 and let's plug it into the scale, all of them just double in scale. That's simple. If it's a 1, it's 1, like so. So this integer value is a rectangle, which means each one of them has the same integer value of scale. The diamond, however, is different. And let me just actually divide it by 20 just for the sake of, or run by 10 just to make this easier. The diamond, however, is different because the diamond means a unique value for each point. So, for example, with the index, it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which means that if we plug in the diamond, they increase in scale. That's the fields. You need to be careful when something accepts a diamond versus when something accepts a rectangle, so when something accepts a constant versus a variable, effectively. We can have the same thing with position, where we can repeat the process exactly with position, like so. And there we go. Now it varies depending on the position of each point. This should be simple enough, I hope. I mean, this is like the most crucial part of geometry nodes, so I do hope you understand it. I'm thinking if there's something that I could actually... Hold on, because there is an animation I also need to work on in the background, so let me just render it real quick. Before we continue chatting. You can actually see me apply this already. So this one is the Lagrangian, then we're going to have the Hamiltonian, which will be very similar, the only difference being that... Well, actually no, it will be identical. The only difference being that this one will be blue, and it will be addition. Well, actually that's pretty dumb because they... Well, you know what? No, I actually like it. Should be clear. I may have to play around with them for a bit. Yeah, okay, that's good. I think I should already give you a bit of a task. It's something that I do in my videos a lot, and oh no, that might be a bit challenging. No, it might be a bit early for a task. Instead, I will give you an example and I'll just let you play around with it on your own. So, I know that you like a challenge, that's fine, but the problem is more in the fact that you don't have the knowledge, which means that if I just give you a task, then it will take you 16 hours just because I haven't explained this one crucial piece of information. So instead I'm going to give you an example and you should play around with, you should try to replicate it or you should try to expand it on your own. Or plus the 100. Okay, so right here we have a grid, and you should understand actually what this means already. We have a grid of size 10x, this change the size, and made up of this many vertices on each side. Once again, that's something I'm certain you could figure out on your own. The interesting part happens when we take the position node, because now if we use the position node, what is it going to be? Well, it's going to be different for each point that makes up this grid. As well, I added this empty right here. Empty is a type of object in Blender that does absolutely nothing. Now, it does feel a bit weird to have an object that does absolutely nothing, but there's a point. That's because we can select this empty, and if it does nothing, that means it won't appear in our animations, it won't screw with our simulations, it will just do nothing. And the reason why it's useful is because we can get object info out of it. For example, its location. So now, if we do vector math, like so, if we take these two and if we check their distance, what will happen? Well, we're going to get a different distance for each point on this grid. So, set position. I'm going to represent it with position because I could also represent it with color like I would normally do with my videos, but that requires a bit of a different setup. We'll get into it in the future. Set position node sets position, self-explanatory. So if we take that distance, combine XYZ, like so, plug it into the offset, and just for the sake of simplicity, we invert it. For the sake of simplicity, once again, we can do 3 divided by it, or 2 divided by it. Plug it into Z, this is what we get. We get the grid to go up depending on the position of the point. I can actually, using a color ramp like so, make this a bit more visible just for the purposes of visualizing it better. There we go. As you can see. Do I find distance using Shift A? Distance is a vector math node. So there is a math node, like so, and math node has a whole bunch of options you can do, a whole bunch of math operations. The same thing happens with distance. Distance is just sake of convenience because you could also do it manually actually, as in separate XYZ, like so. Then we square the x, actually no, we need the two vectors, we need the vector of this and we need the vector of this, like so. Then we subtract them together, we square them, and we repeat the process for each one of these. And then we just add them up. And if my math is correct, which I hope it is, because I'm a bit so that I could have gotten it wrong, this should be equivalent to distance. It is way smaller for some reason because I clearly messed something up. Well, my math is apparently off. Is it not? Oh, root, obviously. I've forgotten about the root. Which we can also do power 0.5, it doesn't really matter. There's also square root of 1, I was thinking this is easier. There we go. Equivalent. So you have the vector math node, which just does mathematics on a vector. That should be trivial. With that in mind, I'm thinking, because on one hand, there is a lot of things I can mention, like genuinely an awful lot. And I'm thinking what would be best to mention first. I would already suggest you play around with this a bit. So for example, oh, this is a neat one, hold on, this is a neat one. So I didn't quite get it with the math nodes. Not how to work, but how to find them. Shift A, math, gives you the math. Shift A, vector math, gives you the vector math. And then you click on the options and you can add them, you can subtract them, you can multiply. add, subtract, multiply, divide, multiply, add, cross product, project, reflect, refract, face, forward, dot product, distance, length, scale, normalize, absolute, power, sign, minimum, etc. And even better, they all have a highlighted letter, because if you press that letter on your keyboard, then it just picks that option. That's just for the sake of convenience. I think I do have a task for you then, if you'd like to complete it already, based on just this limited knowledge. But first, I would like to make sure that this setup makes sense. Let me just compress it ever so slightly, so that it looks a bit cleaner. Oh yeah, and the color ramp, I suppose, that I haven't explained. It doesn't really matter because it works the same exact way without the color ramp. It's just that the color ramp is a map. So it takes in some kind of value between 0 and 1, and then it maps it onto that color. So if a value is 0, it will pick black right here. If a value is 0.5, it will pick black. If a value is 0.75, it will pick this color, etc., etc. Like this. Okay. Let me know if everything makes sense, and if it does, I will give you already something that you could try doing, which it won't require any new knowledge, if I'm not mistaken. I think it makes sense, but can you send me a screenshot of your notes so I can check which... Yes, absolutely. I can even do one better. I can just send you... I can send you the file. That's actually a really good idea, you know? I didn't even think of it, but when I'm teaching Blender, I could just pick certain setups that I already have created and then just send them out. So, right here, I'm going to send you the file. And then, I'm just going to wait till you say that you are still actively watching the stream, just to make sure that I don't say it into the void, because I do have a pretty neat thing that you can try figuring out how to do. Okay, good. Then, based on that setup I have provided you with, I would like you to recreate, not with color, because color we'll tackle another time, because that requires shader nodes, that I will explain another time, but with depth, with height. I would like you to recreate one of the older animations of mine. And that is specifically, I would like you to recreate. Where is it? There we go. This. I would like you to recreate this, as in geometry nodes that give you these kinds of waves. They don't have to automatically process in time. I will mention how to do that later as well. Not overwhelm, but waves, and also waves that interfere with each other. Because based on what I told you so far, you can actually do it already. This won't require Blender skills, this will require math skills. And in this scenario, I would say it's Blender knowledge and math skills that actually matters. Blender won't require all the many skills, it will require knowledge. The mathematics is what's important. So I would like you to try to do this sort of thing with these nodes. How would I represent quantum? I imagine the easiest way to represent quantum would be like this. Like you have this fear, if AIs are learning of human data, what if it gets to a state where they can do everything we humans can do right now, but better than us, but not create post-scarcity by a lifetime? Well, if they can do everything we can do, that would be post-scarcity, because, well, we just wouldn't work at all. But at the same time,
That only works though if they can do everything that we can do.
exactly. Actually, it only
Because
needs.
if a single person needs to work, then we're not post-scarcity technically, because there would still need to be some sort of system where everybody is incentivized to work.
Yes. So, first of all, AI getting to a point where it can do everything that humans can do is pretty far in the future. Like, AI hasn't really improved that much in past couple of years. It did improve crazy lot between like 2018 and 2022, but 2022 to now, it really hasn't that much. So what if they can do everything we can do, but only like 20% faster? They will process science only 20% faster rate. That's still a place of jobs. Well, that's the thing. There is no way that AI could do everything humans can do and do it like only marginally better. There is no way for that, because if AI can do everything that humans can do, that means that includes improving AIs. That's exponential. That exponential can be very slow if you want to be extremely pessimistic, but it's still an exponential.
Absolutely.
But at the same time, once again, you're talking about something that's going to happen pretty far in the future. Okay, how do we tackle this? So this one is -1 to 1. We don't want -1 to 1. We want add 1, divide by 2. This gives us 0 to 1. Then add 1. No, wait, multiply by 2. And then subtract 1. I think I might have do too many levels. No, I think it's good. I overrode the goddamn. Oh, I can't believe I did that. Like an idiot. 60. I overruled it like Ranjan, that's fine. Okay, right here we need to find a function. We need a function that would imitate the object getting hit. So it's, well, I think actually it's inverse exponential, would it not be? I believe it would be inverse exponential. What if it can do everything better than us, except improving AI? There's good normal computers who like servers. That is an unbelievably weird scenario. That's so specific. That's kind of like saying, what if humans can create faster than light travel, but not travel at 1.5 times the speed of light? So what if humans could travel at the speed of light, at 3 times the speed of light, but not 1.5? That's like so hyper specific. Why would it be able to do everything except AI research? It's not hard to imagine. I just realized monitors need more computers after. It's not about. Just monitors need more computer hardware after some point. It's not about software improvement. Well. Sorry, hold on. What? It's not hard to imagine. The guy just realized monitors need more computer hardware after some point. It's not about software improvement. I mean, eventually, obviously, we need hardware, but also there is distillation that exists as a concept. We just iteratively improve them without a need for anything fancy. You are talking about the scenario that's first of all really far in the future, and second of all with something that's such an unlikely and hyper-specific problem. Once again, it's kind of like, well, yeah, it's the speed of light thing, as I mentioned. You're putting this hyper-specific gap in the middle. If it can actually replace all of humans, then it would need to do things like, well, it would need to be able to do scientific research. There really isn't a task that requires more like creativity than scientific research. If it can do that, then it not being able to just improve AIs is so baffling. Let's say it takes 60 years for some AI to help us reach abundance, but only 5-10 years to be better than everything. Then how we survive the 50 years in between?
What?
Once again, that's such so. That's so hyper-specific. I mean, in that scenario, yeah, it's going to be weird. That's going to be certainly quite weird.
We'll survive. Like, why shouldn't we?
But at the same time, why would that scenario happen? That's what I don't understand. Because if you're saying that in these 10 years, all possibilities that could happen just as much as other scenarios, no. I mean, yeah, they could happen, that is true, but they would be unbelievably unlikely. If you want something to worry about nuclear winter. That's a much more likely and catastrophic scenario.
Absolutely.
Climate change is also something you can worry about. If you're looking for something to worry about, there are a lot more things that are a lot more both dangerous and likely than the scenario you're given. I would even say that a more likely scenario is, I don't know, AI being better at, than humans, but like running out of power. That's also a scenario. In which case humans would still do everything simply because then the AI would have to be delegated to only the tasks which we deem most appropriate. And that wouldn't really change anything. That would be basically like current system except slight changes. That is such a hyper-specific and hyper-unlikely problem. I think we moved past the time where we need to worry about nuclear winter.
I wouldn't say that. Like, nuclear winter is always an option.
Yeah.
As long as nuclear weapons exist.
For quite a while, we've been living just casually in this scenario where a single country can just like eliminate the entire planet. And there are a couple of countries actually that can do that. Isn't that fun?
Even France can do that.
Our global economy is so interconnected that would be a bad idea for anyone to use nukes.
Yeah, but like, what if they don't have self-preservation? Ever thought about that?
Have you seen what America's been doing recently? I would argue they have sacrificed their interconnected trade quite significantly.
Yep, and they're still surviving. Well, surviving, as in the definition of the word.
You are worrying about the scenario that is far in the future, extremely unlikely, and to be frankly honest, wouldn't be that bad.
Yeah,
it wouldn't
be kind of awesome.
It wouldn't be. I see weird problems with it, but it's nowhere close to nukes. All the tame stuff when compared. Yeah, it is. I mean, if you disregard all the wars and such, then it's nowhere close to nukes. Still, orders of magnitude more likely than the scenario you've described. Is this I heard climate change is Where did you hear that climate change is reversing?
Where?
We're reversing, well, not reversing, but we're slowing down the rate at which we're causing climate change. But we are still like firmly fucking it up. I honestly just pulled out the internet because I'm thinking which graph to pull, but there's so many good ones. Levels of emissions, future forecasts. I heard some YouTubers say ozone holes are getting patched. Yeah, but ozone holes are such an old thing. For how many years ago? Oh, was it 40? 50? Oh, when were ozone holes discovered? Discovery of ozone holes. Two things. First of all, ozone holes are not climate change. I mean, they are a type of climate change, but ozone holes are more specifically about the ozone layer being damaged.
They're
not about
contributing to climate change.
Yeah, ozone holes are about the ozone layer being damaged, whilst climate change, a much bigger issue is the greenhouse gas effect of the heat being trapped. So
where everybody uses the fuck-ass diagram or graphic.
Ozone holes.
Which everybody uses.
When they discovered the ozone hole, yes. 1985, yeah, so it's 40 years. I've got it basically spot on. Yeah, the reason why
Yeah, ozone holes are
the reason
getting
why
patched.
ozone holes are getting patched is because we decided to fix it. We haven't done that with the climate change, unfortunately.
Because we've decided to not use those products anymore that were causing ozone holes.
I think it's gonna worry about AI. It's because for things like nuclear winter, climate change, it's easier to predict what can go wrong, unlike AI. But the ramifications are, how should I put this, slightly more pressing. You see, if you are in a car that's driving directly towards a canyon, then I would say, yeah, it's easier to see what's gonna happen when that car falls off a canyon than what's gonna happen if you get cancer. However, if I'm in a car that's driving full on into a canyon, I would first focus on stopping the car, not curing cancer. Cancer is worse, but situation at hand, priorities.
Or cancer could be worse
Yeah.
for you. No, like, wait, you said that you were driving towards a canyon and you had cancer, right?
No, I'm saying that you're driving towards canyon.
No.
Also.
I would say that.
Hold on, because Jay just said no. You should read. I have no muffin on my screen. Fire away, buddy. I have made videos about this topic. I have made videos before I've made quantum
Emmy.
mechanics videos. Hi there, Emmy. How you doing? Emmy, I would like to warn you. We're talking about some pretty rough stuff. You've joined. The entire stream has been so lovely and fun. You've joined in at a time when we're just discussing just catastrophes. I'm really sorry for that. Am I correct to assume that I need I for the waves? You are in fact incorrect. You do not need complex numbers.
Alright. Currently driving towards a canyon and you have cancer. Which one should you worry about?
The reason why
That's how.
the reason why I
should have
didn't
phrased
want.
it.
I mean, yeah, I suppose I see your point. Because
Because
that video is still on YouTube. Yeah, the video is still on YouTube. It's this one. Where's the worst mistake humanity could ever make? It's about misaligned AIs. The argument it's making is, I can summarize. It's one of my favorite videos that I've made, and it has 8,000 views because it's right before my channel blew up in any way, shape, or form. I had like 500 subscribers at the time. But the main point of the video is that hyper-intelligent AI is a really powerful tool, and because it's a powerful tool, it could either turn life into heaven and turn into greatest thing ever, or it could turn it into the worst thing ever. Hence, worst mistake, because worst mistake in chess, I used chess as an example at the beginning, worst mistake in chess isn't losing, it's having the opportunity to win in one move, but instead forcing your opponent to win against you. That's the worst move. Nuclear winter or climate change can't wire all of us humans. Some will surely survive in current situation, but AI can. Nuclear winter and climate change also can if we, well, climate change maybe not. Nuclear winter can.
No, climate change probably won't.
But nuclear winter absolutely can.
Because the human body has the incredible ability to sweat.
I don't think.
Therefore,
Yeah.
exactly, who cares if a couple of species die out?
If nuclear winter will recover, we can go into bunkers and do bunker farming. I'm sorry, Jay, with all due disrespect, if a nuke were to fall, not even in the place where you are, only like around the place where you live, is there really a bunker you can go to?
Unless you have your own.
If you have your own, then you probably wouldn't be able to farm in there.
Yep. This isn't Fallout.
Do I need sine, cosine, or something like that for wave? You do. Yes, there is sine inside the math function. Sine math node. You can see that there is sine. Jay, the problem is that you are trying to convince me of something that I have thought about a lot. That's my fear of them. I am highly skeptical of the kinds of content you're watching, honestly, because if you also have seen videos that said that climate change is reversing, and you think of it as a solved problem, I find that skeptical.
Also on the topic of climate change, might have to get a little bit political in here, apparently. That is a political topic. But I think it's funny that Germany has essentially ruined its economy just to save a few percentages of carbon.
I mean, okay, what happened in Germany was idiotic because you had a
Yeah.
Green Party going against nuclear.
Yeah.
Which is just, why? What do you mean?
Which is stupid.
What do you mean a Green Party going against nuclear? This is like what happened in Germany isn't really an example of like why environmentalists are bad. It's an example of why populism is bad.
No. Yeah, I didn't say environmentalism is bad.
Oh, sorry, I didn't mean to put words in my mouth. That was
I'm
like
not
my
a-
opinion.
The only thing that I'm not when you say environmentalism is left. Like, because environmentalism is generally correlated with the left. I personally think environmentalism is important.
Just with you, they got good points, but some things are plain stupid. They really are. It's so baffling to me. Why would a party that wants to support the environment go against nuclear energy? The only explanation was that because it allowed them for an easier win because they could fearmonger. But I mean, that's you just sold out your ideas for a political win, and now you've crashed and burned, and you fucking deserve it. This is what happens when you don't have a spine. Oh my
This is
goodness!
what
Lord,
happens
I-
when democracy is let loose and, you know.
Yeah, I agree. That's why I think I should have all the money. I should just decide.
No, that's not democracy.
Yeah, no, I know.
That is not connected with democracy. Money isn't connected with democracy. Also, you have an allergy to money.
Oh yeah, you don't know, maybe. Oh no, I'm not gonna make that joke. I was about to make no. Nuclear energy got a really bad rep during 70s and later. Yeah, but the problem there is that they've just chosen to fearmonger using that bad rep instead of trying to repair it. When repairing it is what's actually needed. Because nuclear energy is brilliant.
Even though I hate France on here, I do have to say, they have a good energy system.
Yeah, the French have nailed something. Gotta hate the French, but at the
Yeah.
same time, well, it's not. We have
Gotta
ice.
tell the truth.
Yeah,
when you
gotta-
gotta tell
yeah.
the truth.
When it's fair, it's fair. Also, I personally, if we may move to a little bit of a nice topic, I personally really like solar energy. Simply because it's the only one that doesn't require heat. Every single other one is just, oh yeah, let's boil water. Except solar. Solar is actually futuristic.
True.
What is solar?
True.
Oh, you see, we have these we have these two materials, and basically when a single particle of light, a wave particle, hits them, it gives enough energy to separate it into a whole and a free electron. Like, isn't solar bad for the environment because of battery? Energy storage isn't a net positive or a negative. It depends on the scenario. But solar on its own is really good for the environment because it's basically free.
Mhm.
If you want to
Also, Adrian, this is not a political channel. So, on your comment on German politics,
yeah, so unfortunately we can't go into AFD. That's a
Yeah.
whole other
we
kind of
can do
worms.
that in private VC,
Yeah, you can do.
but like,
Exactly.
or like in general VC.
In private VC.
Yeah, sun is literally
of-
just throwing energy at us. We just gotta figure out how to get it well and unexploded.
We
simply-
already know how to get it how
Yeah.
to get it well and unexplosively. It's just that it's
Mm.
slightly more inconvenient.
Person invents new source of energy generation. And where's the part where it just boils water?
But that's genuinely,
real.
can anyone here name me a source of energy other than solar that doesn't depend on spinning a rotor? At
I
least
mean-
one.
I've seen solar power that spins rotors.
Yeah, okay, you can do that if you really want to. I know, I've seen as well. But make it. What is your opinion on electric cars? I think cars in general are overrated. So I
I
wouldn't.
mean, in cities, absolutely.
I would say that electric cars are better than gasoline cars simply because gasoline cars are caveman technology of, oh yeah, we need to blow things up inside our car for it to move. So they have.
That is really fucking metal. I do have to
That
say.
is true. I would say that electric cars an improvement, but cars overall are just overrated. We have too many cars in general.
Yeah, generally in cities you should have a public transit network that actually works
Yes,
and gets you
exactly.
from place to place and
And
is preferable to cars.
and even in between the cities, there are certainly. I'm not saying that cars should be completely abolished because there are certainly a lot of scenarios in which cars are useful. But even then, how often has someone traveled? Unless you're going on a vacation, I suppose. But even then, getting a car might be inconvenient. When it comes to my travel, for example, I usually travel with a backpack and a bag, and the only reason why I have a bag is because I have my camera equipment in it. Otherwise, I would just travel with a backpack on my own. So if I go to the Netherlands, I would just take train. Make it a goddamn waves. That's good. However, I will ask you, Adrian, if those waves are disappearing over time. Because that is a really neat puzzle that I think... But not the interference. Okay, then I'll pause with this. Cars necessary to fight apocalypse when public transport stop working.
Energy production is just something being spun.
Yeah, exactly. I can't even think of
Yes.
something that isn't spun that's not solar. Solar is the only one I can think of that isn't about spinning.
I mean, you could theoretically have those thermal thingy patches that move heat from one side to the other and just reverse the process,
Oh, I suppose.
but I'm pretty sure they're really inefficient.
Yeah.
Fish.
They...
What?
Electrolysis.
Electrolysis. I mean, but
No,
creating-
No, wait, what? No, electrolysis still needs to spin because electrolysis is about generation of heat.
Yeah.
Because electrolysis goes backwards.
You're
Electrolysis...
still boiling water.
Yeah, electrolysis. Electrolysis is about turning water into hydrogen and oxygen. I'm pretty certain what you're thinking is the reverse of the process where you're just burning hydrogen. Because
But then you're
electrolysis...
still spinning stuff.
Exactly, because electrolysis doesn't generate energy, it takes energy.
What else?
I
could
still
you-
am having a bit of trouble getting over the cars are necessary to survive apocalypses, to be honest.
I mean, even a black hole generator would need is pretty much still solar.
Yeah, it's the only two kinds of... There are two roads you can take. You can take heat / spinning wheel or solar.
This is what this nuclear energy is. It's just boiling water.
All of it is boiling water. All of it.
It's so stupid. Like, not even coal power plants, which are metal as fuck, they're still boiling water. Guess lightning fucked the storm. Go ahead, you little pee-pee boy. I haven't played too much Minecraft, I just wanted to change the height and I used Y, which is in Minecraft the coordinates for height. Gotta fix my bike, the gears are clunky. Can't wait for summer. Gotta say I'm a professional summer hater. Why? Because sweating and mosquitoes. They like me some good old winter. Because all you need is a good thyroid.
Wait, did you just say all you need is a good thyroid?
Yeah.
That's actually pretty funny.
No, because the thyroid does heat regulation, doesn't it?
Yeah, I mean, I'm not saying it's not scientifically accurate. I'm just saying it is funny.
I mean, yeah, my gym bro says that.
I personally know someone who actually has a sucky thyroid, let's call it, which is probably why I find it so funny.
Spring and autumn is better. Summer is good to.
Those electrochemical cells. Can they create energy with just chemistry and electrons thrown into metals, not rotating motors? Yeah, but what you're describing is a battery. That's just battery.
True. That is
I
just
mean,
a battery.
yeah, you can create energy, I suppose, that way, but it's not really an energy generator. You just build it once and it has an energy. That's it.
Can't really fuel it.
Yes. I mean, I suppose if you keep replacing the chemicals for it, I see your argument.
Yeah, but
It's-
like, is that really possible
It's-
to practically do?
It is. It's just that no one does it because it's like you need a certain chemical to generate electricity, and it's very like expensive in comparison to how much you generate.
Guess so.
But I suppose point taken, that does theoretically exist.
I guess.
So this function is just wrong.
No, it's still only spinning blades or solar.
It is way too much of a...
It does a lot for metabolism, energy. Use heat regulation. Yeah, my thyroid is okay, but for some reason my circulation is shit. And anything under 5C is pretty dangerous for me to exist for long. Damn. Damn. Maybe you got iron deficiency? Fish. I mean, in general, if you're not eating like a lot of meat, you should probably take iron supplements. Because, you know, or raw liver. Either one works.
My favorite pastime snuck.
Mm.
I'm getting feelings with them ways getting weaker. The problem is that I don't know how to get a second empty object. Press on the empty and then shift D. That's how you duplicate things if you like another empty.
Jeez, ME.
It's like
Pretty sure you should take iron supplements.
Yesterday I was going through stuff in life, and so, but yeah, there you have the empty, shift D, and that duplicates. Now we have two of them, and then you click to select which object you want. It does. Yesterday I went out because I was just going through a lot, and it was something like minus 17 degrees Celsius, something like that, and so I just took off my coat for the last 10 minutes of the walk because I just felt like I needed to cool off, and then I couldn't fall asleep for the next 2 hours because my body was just stuck in a permanent like fight or flight response.
I think that might have something else to do with something else,
It could.
and not that you took up your coats for the last 15 minutes.
because I overrode the Lagrangian oscillator because, well, I messed up. Let's run it again. Oh, it's classical. Oh, they overwrite it like that, really? Oh, and I overrode the one thing after another, right? It's fine. Yes. I can't stare for the room for too long, or weird things that happen. I don't have. But, yeah.
What? What is smegma?
I've been pushed some dark places. I've even tried meditation recently.
Mm.
That's how.
You know that meditation can actually cause psychotic symptoms?
Can't have shit in this house, honestly.
No, seriously.
That's not great.
If you're not careful, it can actually cause psychotic symptoms.
Also, Emmy just called you a bad boy.
Oh my.
Bye, Emmy. Have a good one. Two objects creating waves interfere and they get weaker over time. That is actually genuinely brilliant, Agent. That is genuinely brilliant because that's not an easy thing to do. So now, okay, now I can give you another challenge then. Would it be another challenge? Let me think. Because this could be a bit complicated. Ideally something related to it. Actually, I can go to my YouTube channel and find something. Because I don't want anything too complicated, but at the same time, because I haven't introduced repetition yet. Is this the animation video of harmonic oscillator you're working on? I mean, this is just for the intro, as in, this right here is just for the intro. I just mentioned the harmonic oscillators. Later on I have a whole bunch of other animations. I'm trying to think if there would be something. Okay, I think I've got something good for you, Agent. It will require a little bit more knowledge, so I hope you're fine with it. So, attention pay, and I shall make some notes happen. So, we have a cube. The cube actually doesn't matter because the cube doesn't actually matter because it can be anything. Yeah, we're gonna remove the cube anyway. I'm going to go through it a bit quicker, but that's because I just genuinely remembered that I can just send you the Blender file afterwards, which means that don't know how it happened because everything is correct, but offset a bit. I think it's because sine of 0 is 0 and that should be 1. Could you send me the Blender file so I can see the error? here's the plan, I think. Here's what's going to happen. I think I'll be ending the stream now because I'm getting quite peckish and I would really like to eat something. I will, after the stream, I will keep on working on this video, and despite it being pretty optimistic, I will say, I will try to finish this video today, hopefully. Don't know if I'll be able to do that, but tomorrow it will definitely be finished. That's at least nice. After the stream, I'll also record, I'll try recording some tutorials. Hi Rush, you've joined at the very end. I'll try to record some tutorials for the Blender, and with that in mind, I will also try to think of some really neat things that could actually be created using the tasks at hand. And that's it, I suppose. That's the plan for today. And I suppose for now, that'll be it. Thank you everyone so much for watching and have a great day.